What's up, guys? So you finally decided to start learning how to code. It's going to be an amazing journey, and this is the first step. So in this course, we are going to be going over the fundamentals of programming using Swift, one of the most powerful, versatile, and beginner-friendly languages out there. I'm Stefan, your instructor and founder here at AppStuff, and I'm here to teach you how to code. A little bit about me: I'm a former senior software engineer at Meta. I have almost 10 years of experience as a professional software engineer, and I've also helped tens of thousands of students around the world become software engineers and completely changed their life by making more money, working less hours, and working fully remote. I know, it sounds like a dream come true. And believe it or not, guys, I actually taught myself how to code. I didn't have a background in computer science or anything like that, and you don't need one to become a software engineer. I started off exactly where you are right now, knowing absolutely nothing about programming. So I know exactly what you're going through, and more importantly, what it takes to succeed here. And to give you guys an idea of what you can accomplish, within 1 year of writing my very first line of code, I was making over 6 figures as a professional software engineer. And within 5 years, I was making over $300,000 a year working at an awesome company like Meta. And it's not just me, I've helped thousands of people do the same. That's living proof that coding can really transform your life and your career, guys. And that's not a joke, okay? This is a really valuable and marketable skill. You're not trying to learn how to drop ship or something like that, right? You're learning a skill that is in extreme demand. There are almost 80,000 jobs a year in the US alone that are unfilled for software engineers. So taking the first step with this fundamentals course is exactly what you guys need to get started in your journey. So let's talk a little bit about what we're going to be learning in this course. As I said before, it's all about the fundamentals. It's phase 1 of this amazing bootcamp that I've put together for you guys to take you from zero to becoming a paid professional software engineer. We're going to build a solid foundation before we try to move on to the more intermediate and advanced concepts. So we're going to be covering things like data structures, variables, constants, classes, all of the basic building blocks to become a software engineer and learn how to program. Think of it as building a strong foundation for a towering skyscraper. Whether you aspire to develop mobile apps, work on back-end systems, build websites, or even venture into the exciting realms of artificial intelligence and machine learning, this course is going to give you the necessary skills you need to bring your ideas to life. No matter your background or prior experience, this course is designed to cater to both complete beginners and those who just want to deepen their understanding of the fundamentals of programming. By the end, you will possess a solid foundation in coding that's going to get you one step closer to becoming a software engineer and achieving financial and professional freedom. So in the next section, we're going to go over everything that you need to get started. So let's go ahead and dive in. So first and foremost, you are going to need an Apple computer. Swift, which is the language we're going to be writing our code in and learning our fundamentals with, is developed by Apple, and it's designed to primarily work with Apple devices, macOS, iOS, tvOS, all of that stuff. So you're going to need some sort of Apple computer before we get started. Next, you are going to need an application called Xcode. So this is what's known as our integrated development environment, or IDE, which is just a fancy way of saying that's the place we're going to write, debug, and test all of our code. So lucky for us, it's available for free on the Mac App Store. So we're going to go over how to download that now, and then we're going to open Xcode up and get it all set up before we start with our coding modules. So go ahead and open up your App Store app on your Apple computer, guys, and we're going to go up to the search bar here, and we are going to search for Xcode. And you're just going to hit enter, and we are going to select this option here, the one that says Developer Tools, and we can just click on that. And you guys are going to want to just go ahead and download this. It is going to take you a little bit of time to get this downloaded and installed on your computer. So while that downloads, just go ahead and pause the video and come back when it's finished so we can go over how to get Xcode set up so that we can start coding. So once that finishes downloading, guys, you should see an option to open that up. And if you don't, Xcode should be located in your applications folder if you go to Finder. So once you get that open, you should be presented with a window that looks something like this. So we are going to click on this create new project option. So let's go ahead and just click on that there. And then you should see a window that looks something like this. So we are not going to be selecting an iOS app. That is going to come later in the app development fundamentals course. We are going to just go over to this other tab right here and select this empty option. And then we are going to hit next. And I'm going to call this like fundamentals bootcamp and go ahead and hit next. And then just hit create, guys. You could add that to any sort of project directory that you want. And this is what Xcode will look like now. Don't worry about anything that you see here. What I want us to do is start by going over to this menu on the left-hand side. And we're going to be creating our first coding file that we're going to pick up with in the next video to get started with actually writing some code. So on your project name in this little left side menu here, you can just right click on that and then say new file, guys. And we are going to go up to this filter bar and we're going to select or search for blank, and we're going to select this option as a blank playground. Hit next, and we're going to call this guy variables. Hit create, and that should create a blank file for you that looks like this. You should see this import UI kit and var greeting equals hello playground. Don't worry about what those things are right now. But first thing I want to do, guys, is customize our editor a little bit. And when I say editor, I mean this whole area where we can type code into. So this is currently in light mode, and I strongly prefer using dark mode. So you can go up to Xcode up at the top here in your toolbar, go to settings, and you guys should go over to the themes option that you see here, and you guys will be able to see that you'll be able to select from a bunch of different themes. So I'm going to select presentation dark, and that's just because it's the largest font size and it's in dark mode. So go ahead and select whichever option you guys prefer. You might prefer light mode. I personally prefer dark mode. And that's going to wrap it up for our project setup, guys. It was super easy, and we're actually ready to get started with writing code and learning the fundamentals of programming. Before we do that, I'm just going to give you guys a brief rundown of what programming is at its core in the next video, so we have a better understanding of what this stuff is before we just jump into writing code. So we'll see you guys there. I'm excited to get started. Let's go. Peace. So before we get started with writing our very first few lines of code, I want us to go over a high-level overview of what exactly programming is and how it works. A lot of you watching this video probably have some preconceived notions about what programming is and what programmers look like and what they do, and it probably looks something like this. But it's really not that serious, right? So essentially programming is just the art of giving a computer instructions. We're just telling a computer what to do, telling it to execute certain tasks or pieces of functionality. And that's all it is. So if we take a look at what we have open in Xcode now, this is what's known as an editor. So this is essentially where we're going to write our code. So when we write code in a programming language like Swift, which is what we're going to be doing, computers don't understand that directly. They only understand instructions written in a low-level language called machine code, which consists of zeros and ones. That's probably something you guys have heard of before, but thankfully we don't have to write code in zeros and ones, right? We can write stuff in plain English, sort of like this, and our computer will process that code under the hood, so to speak. So a compiler is a special program that takes the code you write in a high-level programming language like Swift and translates it into machine code that the computer can understand and ultimately execute. Now that might produce an algorithm, that might produce a game, that might produce an app, that might produce a website. It all depends on the code that you write and the language that you write it in and the thing that is ultimately processing your code. So if we were to hit this play button right here, that is going to initialize the action of actually processing and compiling this code that we see on the screen here. Now this isn't actually going to do anything. We haven't actually written a program yet. We need to crawl before we can walk, but that's the process that it initially initiates. It's that process of translating the code that we see here into machine code so that the computer can process and ultimately run that code or that program. So in this case, guys, we are going to be writing code in Swift. We are going to be running that code using Xcode, which is the application that we are writing our code in, and then our Apple computer is going to process that code and give us the result that we need, which eventually is going to be iPhone apps. And before we hop into the next module where we're actually going to start coding, I want to show you guys how to add something called comments to your code. So let's go back into Xcode, and really quickly, guys, a comment is a piece of text that's added to the code solely for the purpose of providing information or explanations to human readers, and it gets completely ignored by the compiler when the program executes. So if we want to add some notes in here, all we have to do is do 2 forward slashes, and you guys will notice that that turns gray. And I could say like, this is a single line comment. So you guys notice if I run my code, nothing happens. This actually gets completely ignored. And the importance of that, once again, is so that we can add notes to our code, so that if we ever come back to it and there was something confusing in there that we might have not really understood fully, you can reference notes like this and write notes like in this way. So you guys notice here, if you look at this like right side menu, this is getting processed by the compiler, but this is not. If you were to remove these, it would try to process this text as actual code, and that doesn't really make sense. So once again, if you just add 2 slashes, that is going to allow you to add notes. So that's a single line comment. You guys would notice if I go to the next line, it's going to start trying to treat that as code again. So I want to show you how to add a multi-line comment. So let's go here, and you're going to do a forward slash and a star, and then just hit space, and you guys will notice that it adds the closing star and slash for you automatically, and you can just hit enter. And then you can now type a comment that is multiple lines. So you could say like, this is a multi, or this is a, and you can hit enter, multi-line comment. Okay, so that is how you write a multi-line comment. This is a single line comment. And then I also want to show you one last thing, and this is going to be how we create like sections in our code. So you're just going to type 2 forward slashes, do a space, type the word mark in all caps with a colon, and then do space, dash, space, and then you can name this section whatever you want. So we could call this like section. So this will indicate to us that, hey, this is like a section of code, and this could become more specific, like, hey, this is section 1, section 2, section 3. So I just wanted to show you guys some of this notation here for how we're going to be adding notes to our code, and this is just going to help keep everything really neat and really organized, so that when you come back to this stuff, it's easy for you to read. So that is going to wrap it up for this section, guys. I just wanted to give you a breakdown of what programming is, how it works, and how to add notes to our code. So in the next video, we are actually going to get started with writing code and actually learning how to program with fundamentals in Swift. So get excited for that, guys. We'll see you there. Peace. What's going on, guys? Hope you're doing well, and welcome to the first module of the course, where we're going to be covering variables and constants. So we're going to start the video off with a brief introduction of what they are, and then we're going to hop into Xcode to actually get some practice with this stuff. So let's go ahead and check out our introduction now, so that you guys have a better understanding of what we're doing before we start coding. So variables and constants, what are they? So essentially, they allow us to store data of particular types and properties, or associate a name with a particular value of a particular type. So let's take a look at this little snapshot that we have down here. We see that we have a couple variables, right? So you guys are going to see this word var here. This indicates that we are creating a variable. This guy is our variable name. And what's on the right side of the equal sign is the value that is being stored inside of that variable. So you can sort of think of it as a container that stores a value of a particular type. So what do I mean by a particular type? Well, you can see here that these are words, and then X and Y are numbers. So variables can have different data types. In this case, first name and last names are words. In programming, we refer to them as strings. And then X and Y in this case are numbers. And the major difference between variables and constants is that variables can be mutated or changed and constants cannot. And we're going to be doing some examples of that once we get started with coding. So just to do a quick wrap up here, guys, variables and constants are simply used to store data in our programs, and we can store different types of data in our variables. We can have strings or words, we can have numbers, and there's a couple other different types that we're going to cover. And I want us to hop into Xcode now and actually get started with doing some examples of this. So hopping into Xcode, guys, the first thing I want to do is paste my notes in here about variables and constants. And I highly recommend you guys pause the video and type this out yourself. Writing things down is really just going to help cement your understanding about the things that we are learning. And I recommend doing this for each module that we have. So to keep going, I'm just going to delete these two comments, and we are going to start with our strings section. So we're just going to go ahead and create a couple more variables, and I'm going to walk you guys through this step by step, literally letter by letter of what we're doing. So the first thing we're going to start by doing is typing out the word var. So this is what's known as a keyword, and it indicates to our compiler that we are creating a variable. You guys notice that as soon as I'm done typing it, it changes color. And that's because the compiler recognizes that as what's known as a keyword, and it indicates to it that we are creating a variable. So then the next step is our variable name. We're going to call it first name. And we're going to go over why things are capitalized in this way in a little bit. Just stick with me for now. Just know that this is done on purpose, okay? And then we're going to say equals, and then you guys are going to open up a single quote, and you can just start typing letters, and it will close the quote out for you. So I'm going to say var first name equals Stefan. So now I've just created a variable called first name, and it's equal to Stefan now. So you guys might be like, okay, cool, we've created a variable, but how exactly do I use it? And what am I going to use it for? So imagine we wanted our program to simply display our name back to us, right? So we're writing a computer program now that is really just going to show me what my name is, right? Super simple, but we got to crawl before we can walk, before we can run. So let's go ahead and see if we can do that. So just go here on line 13 or 14, doesn't matter. And I want you guys to say print and then start typing out that first name guy. And you guys are going to notice that this little window comes up, right? And this is what's known as your autocomplete window. So something that's really cool with programming compilers is that because we've created this as a variable, as I start typing it out, it recognizes that. And it says, oh, hey, dude, I see that you have a variable that looks really similar to this. Huh, that's kind of funny. You want it? You want to use it? All right, cool. Well, let's use it. So you guys can just hit enter. And now what this is going to do is display our name back to us. So if I hit play, it's just going to say Stefan. And you could literally change this to whatever you want. You could say Stefan Dowless. And if I hit play, it's going to display whatever the value of that is. I could also say print greeting, and that comes up in my autocomplete window as well. And then I'll get two print statements back, right? Stefan Dallas, hello playground. So that is just a really simple example of how variables are used, guys. They help us store information, and then we can access that information at any point in our program. And we're going to go over more examples of how they're used in applications and real life programs and stuff like that. We're just starting really small and really simple here. So next up, I'd actually like for you guys to try to see if you could create your own variable. So it's a pretty simple task. Just see if you could create a variable called last name and set it equal to your last name, and then see if you could print it out to the console. Okay, so go ahead and pause the video, see if you can accomplish that, and then come back once you're done. All right, so you guys should have got something that looks like this. Let me just make this my first name, and then I'm going to create another variable called last name equals Dowless, and then I'm going to go here and say print last name. Run my program, and this is what you guys should have gotten back. Now, look, man, if you guys got that right, you don't even need me anymore. Shut the course down, pack it up, go home, you're done. Apply to Facebook, you're going to start making $300K a year. Send it, bro. Get out of here. Why are you? Leave. Bye. It's like, I'm kidding. No, but if you guys really did get that right, give yourselves a pat on the back. You get your first virtual gold star. Blam! And now we're going to move on to creating some different data types with variables. So we've done strings. Now I want us to move on to numbers. So let's go ahead and make a new mark here. So I'm going to say mark numbers. And we can just say var x equals 2 and something like var y equals 3. So let's go ahead and see if we can print these out to the console. It's going to be pretty straightforward, guys. It's just a different data type. I could say like print x and run my program, and it's just going to give me back 2. The interesting thing about numbers, though, is that we can actually apply like mathematical operations to them, and we're going to cover this in more detail in the next video. But for example, guys, I could say like x times y and print that out, and it would give me back 6. You guys would notice that if you tried to do this with the strings, your compiler would give you an error. So like, let's see if we could do that. Let's say print greeting times first name and try to run it. And this is what it's going to look like if you get an error, right? So it's going to say binary operator of multiplication, that little star, cannot be applied to 2 string operands. That's basically just a fancy way of saying, why are you trying to multiply 2 strings? What does that even mean, bro? Like, what do you want from me to do there? I can't do that. Sorry. Bye. So anyway, we could replace these with x times y. And this is just to show you guys that different data types have different capabilities or functionalities associated with them, right? So let's move on to the final data type. And these are the 3 like main types of data that you're going to work with in programming. And it's going to be something called a Boolean. So we're going to say mark Boolean. And Boolean variables are cool because they can only have one of 2 potential values. They can either be true or false. So we could say like var having fun equals true because we're having fun together, right? I hope you guys are. And we could run our program, and you guys will notice on this little right side menu. So this right side menu, guys, if you were confused, it just gives us back the value of everything we're looking at. And then my console only gives me back things I actually tell it to print. So we could see having fun is true. And then I could also like print out having fun if I want to. So print having fun, play, and I can see it's true. And then so you guys can see the other side of things, having fun is false. And if you're not having fun, I'm sorry. I don't mean for it to be that way. I hope it doesn't stay that way. But you guys can see here that it prints out false for us in the console. So Booleans, once again, can have one of 2 potential values, either true or false. And we are going to see how to actually utilize these different data types in programs and applications as the course goes on, guys. This is really just meant to be an introduction to these things, and it's supposed to start laying a foundation for the things that we are going to be building in the future. We're going to be applying these concepts when we're building programs and applications. So this is really just getting your feet wet and getting exposed to this right now. So if you're confused about how we might use these things, don't worry, that will all make sense later on in the course. So the last thing I want to cover, or actually 2 more things I want to cover, guys, is how we can mutate variables and what the difference between a variable and a constant is. So if you guys remember in our notes, we said that variables can be mutated or changed and constants cannot. So for example, let's imagine that I wanted to change the value of one of these variables at any point in my program. So if you guys remember, when my program compiles, it starts at line 1 and it starts working its way down all the way until the last line of code, and it processes things in order, right? This is what's known as synchronous functionality. Things happen line by line, synchronously. So for example, let's see if we can change the value of x and y, right? So I'm going to go below this print statement where we're printing out x and y, and then I'm going to say x equals 4. Oops. X equals 4 and y equals 6. And then I'm going to print x and y again. So you can just highlight this, guys, and hit Command C to copy it and paste it below. And let's run our program again. And you guys will notice that at first it's 6, and that's when x and y are 2 times 3. And then we change them to 4 and 6, and then x times y becomes 24, right? So we notice that here we have mutated or changed the value of our variables. And then when we run this same exact line of code on line 29 as we do on line 24, it uses the updated values of the variables. So we can change the values of variables at any point in our program. So something important to note, guys, is that you don't say like var x equals 4. This would indicate to your compiler that you're trying to create another variable called x. So you guys notice here that one of my errors says ambiguous use of x, and that's because the compiler is getting confused. It says, hey, you've created 2 variables called x. I don't know which one you want me to use. And you've basically turned your computer program into Ryan Gosling from The Notebook.
What do you want? What do you want?
It's not that simple.
What do you want?
And yeah, nobody wants that, right? So essentially, guys, what you want to do when you're modifying a variable is just access the original reference to it, right? So here is the creation of that variable. If I want to modify it, I can just say x equals 4. I don't have to say var x equals 4, because that would indicate to my compiler that I'm trying to create an entirely new variable, and variable names have to be unique so that your compiler doesn't get confused and turn into Ryan Gosling. So let me just do a quick recap as to how this is working before we move on with our constants and how they're different from variables. So really quickly, at the time of this print statement on line 24, when we get 6 back, x and y are 2 and 3 respectively. And then we print that out and it gives us 6. And then on line 26 and 27, we modify x and y to be 4 and 6 respectively. And then on line 29, it gives us back the result with the new values. So it's important to understand, guys, that programming does happen synchronously, meaning it processes this stuff line by line, which is why when we modify these 2 values and then type the exact same line of code on line 24 and 29, it has different results. So now that we've gone over that, let's move on to constants before we wrap up this video. So really quickly, guys, to create a constant is very similar to creating a variable. There's really just one major difference. Instead of saying var, we say let. So I could say like let a equal 5, let b equal 10. And the difference between the two is that variables can be modified or mutated and constants cannot. So if I tried to modify a to be like 20, you guys would notice that my compiler gives me an error and say, hey, you can't modify that, right? Because a is a constant, and constants by definition cannot be changed. They have to remain constant or the same. So a quick example of when you might want to use a constant versus a variable, guys, is let's imagine you have an application that looks at the user's birthday. So like let's have their birth year. It equals 1991. That may or may not be my birth year. I may or may not be old as hell. Just don't tell anybody. Shh, keep it on the down low. But anyway, you would want this to be a constant because you can't change someone's birth year. As much as you might want to be able to, you can't do that. That's just not how it works. So if this were declared as a variable, someone could accidentally say, hey, birth year equals 1996, and I could make myself 5 years younger magically, which would be pretty cool, but I can't do that, right? So that's just a really basic example of when you might want to use a constant versus a variable. And don't really worry too much about when to use one or the other. We'll get plenty of practice with that throughout this bootcamp. So another difference between the two, guys, is that constants require less memory to create. So basically what's happening every time I create a variable is my computer program uses up just a tiny bit of memory. And that's why I can access those things at any point in the program. It's because they're stored in memory. My computer can remember that I've created those things. And variables require more memory because they are changeable or mutable, whereas constants require less memory because they are not mutable. So that's just another difference between the two things. So the last thing I want to cover, guys, is why we have this casing naming convention with our variable names. You guys will notice that the first word is lowercase and then the second word has the first letter uppercase, which is kind of weird, but that's actually considered standard naming convention, and it's mainly for readability, right? So you guys can imagine if I made this like first name and it was all lowercase, it gets harder to read, right? So in order to make this stuff more readable, I just uppercase the first letter of every subsequent word after the first word. You do not, with variable names, uppercase the first letter of the first word. And there's a reason for that. There are other things in programming that get named this way. And to stick to the standard naming convention and not confuse ourselves and other coders that might have to work with our code, there is a standard naming convention and we're going to get tons of practice with that. So just know that this is done on purpose, guys. And even though it might seem a little confusing right now or take some getting used to, I promise you guys that it will become second nature as time goes on. So that's going to wrap it up for the first module, guys. That is just a brief introduction to variables and constants, and it's something that we are going to be using in literally every other single module that we have in this course. It's something that programmers utilize every single day. It's one of the most important building blocks of any programming languages, the ability to store data in properties. So we're going to be moving on to the next video now, where we're going to be covering operators, very similar to what we did with like X times Y. There's a bunch of different ones, and we're going to be going over that in the next video. So we'll see you guys there. Thanks for watching this one. Peace out. What's going on, guys? Welcome back. Hope you are doing well. In this module, we're going to be covering operators in programming. So we got a brief introduction in the last video to this when we did things like X times Y. The operator in that case would be the multiplication symbol. So we have a bunch of different operators and types of operators, and that's what we're going to be covering in this video. So let's go ahead and get started now. So before we hop into the code, guys, let's take a look at the formal definition of an operator. So it's basically a special symbol or phrase that you can use to combine or change values. So we've already seen some examples of this, right? The most basic example are binary operators, where they're simple mathematical operations. We can say X plus Y, X minus Y, X times Y, or X divided by Y, where X and Y are number values. Another example of an operator that we've seen that's a little bit more subtle is something called the assignment operator. So it's a single equal sign, right? So basically, the assignment operator sets the left side param equal to the right side value. So basically what this is saying in plain English is that we are creating a variable and we are assigning this variable first name to the value of Stefan. And for this guy with X and 2, we are assigning the value of 2 to the variable name X. So that's a simple example of an assignment operator. And there's actually a couple more different operation types that we're going to be looking at once we hop into the code, which we're about to do right now. So let's go ahead and hop into Xcode and get started. So to start this off, guys, let's go ahead and create a new playground. So right click on your Bootcamp file name and hit new file. And in the filter up here at the top, once again, just go ahead and search for blank and create a blank playground, hit next, and we're going to call it operators, just like that. And let's go ahead and paste our notes in up at the top. You guys should pause the video to type this out. We don't need this UI kit import right there. But basically, operators are special symbols or phrases that allow you to check, change, or combine values. So let's go ahead and just create a couple sections here. So let's delete this greeting. And the first section we're going to have, guys, is the assignment operator. So this is something that we saw back in our variables playground. It's pretty simple. We just say like, hey, var first name equals Stefan. And in this case, the equal sign is the assignment operator, right? Or var X equals 6. It's assigning the value of 6 to the variable name X. Okay, so that's our assignment operator. And then let's create another mark here for our binary operator. So all this stuff is pretty straightforward, guys. This is going to start getting juicy in just a little bit, where we're going to introduce some new operation types that are going to allow us to do some pretty interesting stuff. So these are the basic, plus, minus, times, and divided by. So we could simply, let me go up here and create another variable y. I could make this like 10. And, you know, we have x plus y, x minus y, x times y, and x divided by y. Let's actually make these, make it so that the x divided by y can work out. So I could make this like 20, right? And then let's just run our program to make sure everything is running smoothly, and pay attention to what you get on the right. Okay, so we don't have to print any of these values. Our console isn't actually giving us back anything, but this right side menu is just giving us back the value of all of these expressions. So 10 plus 20 is 30, 20 minus 10 is 10, and then, you know, the multiplying is 200, and then 20 divided by 10 is 2. So those are the basic mathematical operations. Another pretty cool one that we have is something called a modulo operator. So I could say like x percent y. And you guys might be wondering, you know, what the heck does that do? That looks kind of weird. And this will actually give me back the remainder of the result of the division between the two things. So let's just add a comment here. You can just say remainder. So for example, guys, if I made this 25 and ran my code, x percent y would give me back 5, because the remainder of 25 divided by 10 is 5. So that's another interesting binary operator there. So another interesting example of how to use binary operators, guys, is to notice that we can actually apply the plus operator to a string data type. So really quickly, I want us to just go ahead and create another variable here called I'm in all caps, var last name equals Dowless. And let's see what happens when I say first name plus last name. So this will actually act as a concatenator. Okay, so it'll actually just combine those two things. So you can see it gives me back Stefan Dowless. And you know, there's a certain way to apply spacing between the two things, but we're not really going to worry about that right now. I just wanted to show you guys that you can apply certain binary operators to strings. Mainly, it's really just this plus guy, because the plus serves as a concatenator or a like a combiner between the two strings. So next up, let's create a new section, guys. We're going to call this compound assignment operators. Okay, so I'm going to create another variable here. Let's just call it C, and I'm going to say it's equal to 1. And let's go ahead and type this out. Say C plus equals 2. And let's go ahead and see what that gives us back. So C plus equals 2 gives us back 3. If I made this 5, C plus equals 2 would give me back 7. Let me run that really quickly. Yep, 5, 7. If I made it 10, I'm sure you guys could guess by now that it would give me back 12. So what exactly is this compound assignment operator doing? It's saying, hey, take the current value of the variable and then add 2 to it and make that the new value of the variable, right? So it's saying that this is simply just equal to C equals C plus 2. So it's saying that the new value of C is equal to the current value of C plus 2, which gives you back 10 plus 2, which equals 12, which is why this ultimately evaluates to 12. So I want you guys to try to figure out what the value of this would be. If I said C times equals 2, that's actually going to give me back 24. So if I run this, you'll notice that 24 shows up on the side. You might think it would be 20, right? But you have to understand that we have reassigned the value of C to be 2 greater than what it originally was. So it went from 10 to 12. So then when we say C times equals 2, we get back 24 because 12 times 2 is 24. So to really solidify this concept, guys, I want to show you a real life example of how you might use a compound assignment operator in a real life mobile app. So I'm going to bring up this mock version of Instagram that I have built myself. And this is actually something that we are going to be building in this bootcamp as well. And yes, that is actually me racing a motorcycle, which is kind of cool. But anyway, I want us to pay attention to this likes parameter here, right? So we see that right now my post has 1 like. If I were to like this post, it would go to 2 likes, right? So we have to think about how that works programmatically, right? We have to look at the pre-existing value, which is 1, and then we want to add 1 to that pre-existing value. So 1 plus 1 would equal 2, right? So if I like this, it goes to 2. And similarly, if I were to unlike it, it would go back down to 1. So basically, guys, let's modify this example that we have here to mimic what we see in the application. So I could maybe create this variable to be likes, and I could make it equal to 1, which is what it was currently at when we were looking at the app. And then I could say, hey, if I like the post, likes plus equals 1, and this is equivalent to liking a post. And then if I unlike it, I would say likes minus equals 1, which is unliking the post. So the only thing you really need to take away here, guys, is it just performs some operation on the existing value of the parameter, in this case, likes, and reassigns it to be that new value, right? So likes goes from 1 to 2, or from 2 back down to 1. So that is an example of how you would use a compound assignment operator in a real life mobile application. So next up, guys, we have our last type of operator, and it's known as a comparison operator. So it's simply operators that are going to allow us to compare values to each other. And this is something that you've done literally since 3rd grade. Hey, is this number greater than this number? Is this number less than this number? Is this number equal to this number? Is this number not equal to this number? So on and so forth. So let's go ahead and make a new section for this and call it comparison operators. Okay, so first up, we're going to have is equal to. So I could say, like, let's refer back to x and y. I could say x equal y. And what this is saying is checks if x is equal to y. So the double equal sign here will simply check if x and y are equal to each other. And something interesting about comparison operator, guys, is that they evaluate to true or false. So they give us back a Boolean variable, right? So basically what this statement is saying is, hey, if x and y are equal to each other, it's true. If they're not, it's false. So pay attention to the right side menu here. When I run the code, saying x and y, we're checking if they're equal to each other, and it gives me back false. If I make them equal to each other by saying like x is 25 and y is 25, then it will give me back true. Okay, I'm going to change this back to 10 just so we can see examples of how the other stuff works. So I could also say, hey, check if x is not equal to y. Checks if x is not equal to y. Can't type right now. Sorry, guys. My microphone is like in the way. But basically, this will evaluate to true if x and y are not equal to each other. So it'll basically just be the opposite of this, right? So in this case, x and y are not equal to each other. So this evaluates the true. So another one is x greater than y. Checks if x is greater than y. And this will obviously evaluate to true because 25 is greater than 10. And then we could have like x is less than y, x greater than or equal to y, x less than or equal to y. And I think the rest of this is pretty self-explanatory, right, guys? So this will check if x is less than y. This will check if x is greater than or equal to y. This will check if x is less than or equal to y. So the interesting thing to note about comparison operators is they evaluate to either true or false. So how might that help us out, right? So imagine we're writing some sort of like trading algorithm where we want to program some algorithm to buy and sell stocks at certain points. Well, you would use comparison operators to do that, right? You would say, hey, if the current price is less than 20 bucks, buy the stock. If the current price of the stock is greater than 20 bucks, sell the stock, right? Or hey, if the current price of the stock equals 30 bucks, sell it. If the current price of the stock equals 10 bucks, buy it. So you would use comparison operators to do that, and you could ultimately perform certain operations based on whether or not those conditions are met, whether they evaluate to true or false. So that just gives you guys an idea of how we might utilize comparison operators. So that is going to wrap it up for our module on operators. Guys, we went over a bunch of different types, including assignment operators, binary operators, compound assignment operators, and comparison operators. And we went over some examples of each and how they would be used in real life mobile applications. So we're going to be getting plenty of practice with this stuff as time goes on. So if you don't have a full, complete grasp of it just yet, which I don't expect you to, don't worry about it. I'm telling you, don't stress yourself out about it. We're going to get so much practice with this stuff as the course goes on. So thanks for watching this one, guys. We'll see you in the next one. Hope you enjoyed it. Peace out. What's going on, guys? Welcome back. Hope you're doing well. In this video, we're going to be covering something called string interpolation. And basically what it is it allows us to inject values into a string. And I know that might sound really intimidating and really confusing, but we're going to see what exactly that means here in just a second. So let's go ahead and hop into a brief introduction of what this is, and then we're going to hop into Xcode to do some examples. So string interpolation, what is it? Well, as we said before, it's something that allows us to inject values into a string. So what the heck does that mean? Why do I care? How am I going to use it? Let's go ahead and figure it out now. So looking at this example, let's say we have a variable for the user's age. In my case, it's 31. And then we have an age string that tells them how old they are. So this says you are backslash parenthesis age parenthesis years old, right? So this is just the notation that we need to use to inject this value into the string. That's what I mean by inject. We are taking this value and placing it inside of the string so that ultimately the string gives us back the value of that variable right here. You are 31 years old. So if I changed age to 35, it would say you are 35 years old, so on and so forth. So that's the purpose of string interpolation, guys. And we're going to see how useful this is here in just a second once we hop into the code, which we're going to do right now. So let's go ahead and get Xcode opened up. So we're going to start off by creating a new playground. So right click on Bootcamp and hit new file. And we are going to search for a blank playground file, hit next, and we're going to call this string interpolation. So once again, guys, let's copy and paste our notes. String interpolation allows us to inject values into a string. So let's go ahead and produce an example of that, right? So the one we had in the presentation was var age equals 31 and var age string equals parentheses you are, and then do a backslash, open close parentheses, and say age years old. And let's go ahead and just print out that age string. And as you might expect, it just gives us back, you are 31 years old. So why do we have to do it this way? Well, let's imagine that I removed these, like this sort of wrapper, right? This backslash and parentheses. What do you guys think is going to happen if I do that? Well, it's actually just going to say you are age years old, right? So it's not recognizing that we're trying to treat this as a variable. It's just recognizing this as a couple of letters, and it spells age. So what we need to do to actually inject this value is bring back that notation, right? So I say backslash parentheses age years old. And this allows me to take some sort of number type and inject it into my string. And you guys might be saying, okay, well, why don't you just go here and say you are 31 years old? Well, I'm sure you can imagine the reason for this is if we ever modify the value of this age, it will not be reflected in this age string because we've simply placed this constant, like hard-coded value of 31 in there. So anytime we modify this property, it won't reflect that in the age string if we do it like this. So let's go ahead and see if we can produce that example of like having to compute this property. Right, so let's just create a couple new variables. So we can say let birth year. And for me, it's 1991. And then let current year equal 2023. And then we could say var age equals current year minus birth year, right? So imagine if we didn't know the user's age directly, we had to figure it out based on this. And this is obviously going to say I'm 32, guys. I am turning 32 this year, but I'm not 32 yet. I'm not that old, but you guys get the point, right? So basically now, how would I know how old the user is? I wouldn't just be able to type this value in there. I would have to inject that value, right, of age, and then it would ultimately print my age string and say, hey, you're 32 years old. So this is what happens when we have to perform some sort of calculation to produce a value, right, and ultimately display some sort of dynamic value. Right. And what I mean by dynamic is like we're displaying the age value, but that is computed based off of two other properties. So if we really wanted to make this like correct or good code, we would make the current year property a variable because the current year can obviously change as time goes on. And then if I were to go below this guy and say like current year plus equals 1 and use that assignment operator again. So it would make this 2023 plus 1, which equals 2024. Then my age would recompute to become, current year is 2024 minus birth year. So I would then be 1 year older. So that's what I mean by dynamic values there, guys. So I could say like plus equals 10 to see how old I would be in 10 years, which I don't even want to think about. I'd be 42 years old in 10 years. God, that sounds so scary. I don't want to go there. Please just kill me now. But anyway, let's go ahead and keep going with some more examples, guys, before we end this video. So this doesn't necessarily have to be numbers, right? This could be any sort of variable that we want to inject into a string. So let's imagine I had a name property, or we could bring this first name guy back, Stefan, and then bring this greeting variable back as well. I could say var greeting equals hello. And then I could inject that value with string interpolation and say first name. And then I could print out my greeting. And I'm just going to delete this line of code because I don't want to constantly be reminded that I'm going to be 42 in 10 years. So, all right, guys, it says hello, Stefan, right? So whatever I change this to John, and it would say hello, John. So this allows me to inject some sort of value into a string. So really quickly, let's take a look at what a real life example would look like in this case in a mobile application. So I have an app up here that I'm actually currently building for a client, and it's like a contract management app for the construction projects that they currently have ongoing. But what we're looking at is the top up here, right? It says, hi, Stefan, welcome back. So let's imagine that I can log in as a different user. Like I have multiple businesses that have multiple contracts. So every time I log in, I want this to be some sort of dynamic value, right? Like I don't always just want it to say, hi, Stefan. I want it to say, hi, whatever user I'm logged in as. Hi, Stefan. Hi, John. Hi, business 1. Hi, business 2, whatever that may be. You could apply the same concept to your Instagram accounts, right? If you have multiple Instagram accounts, you could say like, hey, username 1, and then you could log out and log in as your second account, and it would say, hey, username 2, right? So this is the concept of displaying dynamic data within your application, and string interpolation is a big part of that, guys, because it allows us to inject values into a string. So the reason I'm teaching you guys this stuff, because I want to keep coming back to that, right? Like, why am I teaching you what I'm teaching you? What's the purpose of it? Why do I need to know this stuff? And ultimately, what you're trying to do is build mobile applications or build software, right? And at a really simple level, all that is displaying information to a user, right? It might involve performing some sort of calculation to display information to a user. Like if you had some sort of finance app, you might want to display the user's portfolio value, or stocks, you could display their total profit loss. or Instagram displays a list of posts, right? Like you're ultimately just displaying information to a user, and you want the ability to display dynamic data to them, right? You want to be able to perform some sort of calculation or process that will ultimately result in you displaying some sort of piece of information to them that they ultimately value. Right? So string interpolation, like I said, is a big part of that. And these are really, really simple examples, but these are things that are part of the foundation of building software. So that's why we're learning this stuff, guys. And I want us to do one more example before we end this video, just to really cement our understanding of this concept before we move forward. So, what I want us to do is imagine we're trying to display the result of a math problem to a user. Like imagine you're building some sort of education app and you want to display math problem results to a user, right? So let's imagine you want to display the result of some number A times some number B equals some number C, or X times Y equals Z, right? So let's create a variable X, and let's set it equal to 6, and we'll create another variable Y equals 7, and then let's create a variable called product, and it's going to equal X times Y, okay? And let's go ahead and see if we can print out the result of this to the user in plain English. Hey, 6 times 7 equals 42, okay? So we could say let product string equal, and we're going to create some quotes because we're creating a string here. And we want to inject whatever X is times whatever Y is and say it equals whatever this product is. Okay. So we're going to say we want to inject the value of X space. And this is what the plain English part of this is going to be, right? It's like times, or we could even put an X there. Lowercase x, big X, doesn't matter. Y, and we have to inject that value as well, equals, and then we have to inject the product. And ultimately, we want to print out the product string, just like that. So let's see what this gives us back. 6 times 7 equals 42, right? So this gives us back the result of this equation in plain English, right? And like if I change this to big X, it would be 6 like capital X times 7, or I could change it to a star and it would be 6 star 7 equals 42. You guys get the idea, right? So this is just yet another example of how you might use string interpolation in an application to display data to a user, right? We're injecting the value of X, we're injecting the value of Y, and it ultimately equals this product guy. So let's take a look at what would happen if I modify the values of X and Y. For example, I could change X to 9, and I'll notice that if I change X in one place, everything else will update in accordance with that new value, right? So if I change X to 9, my string will ultimately then say 9 times 7 equals 63. And that's because I'm injecting this value of X here. The product is equal to whatever the value of X is times whatever the value of Y is, which is defined up here. So if I changed Y to 10, then I'm sure you guys could figure out what's going to happen. It's going to say 9 times 10 equals 90. So this is just a really good example, guys, to show you how string interpolation is used and also how to use it effectively, right? When you want to display dynamic data to a user in an application, we can simply modify a property in one place and then have that take effect in multiple other computations, right? Like in this product guy and this product string guy. And we're going to get tons of practice with that when we start actually building mobile applications, which is going to come later on in this course. So that is going to wrap it up for this video on string interpolation, guys. Hope you enjoyed it. In the next one, we are going to be getting into logic and control flow in programs, which is another fundamental concept that we're going to need in order to build high quality mobile apps. So hope you guys are excited for that. We'll see you there. Peace out. What's going on, guys? Welcome back. Hope you are doing well. In this module, we're going to be covering something called conditional programming. And what it is essentially just a decision-making process that we can implement within our programs. So it's going to allow us to execute certain pieces of functionality under certain conditions, right? And this is something that we actually do in our everyday lives every single time we make basic decisions, right? For example, you might ask yourself, is it cold outside? Yes, put a hoodie on. If it's not, I can wear t-shirts and shorts, right? Or am I tired? Yes, go to sleep. No, keep watching Netflix, right? So we're just going to go over how to implement that kind of functionality programmatically and then go through some examples of how we might use that in real life applications. So to get this video started, let's just go ahead and check out a brief overview of this stuff, give you guys some visualizations of how this works before we get started with the code. So once again, guys, conditional programming just allows us to execute certain pieces of code under certain conditions. So I want to just show you a visual diagram of what this decision-making process looks like, right? And once again, it's something that we do every day in our day-to-day life. So for example, are you tired? Yes, then you could just go to bed. If you're not, you might keep watching Netflix, right? So basically, based on whether or not this condition is true or false, this am I tired guy, we are going to execute a certain piece of functionality, right? So if we are tired, we go down this path. Yes, go to bed. If not, then we just keep watching Netflix. So before we jump into Xcode and actually implement an example on our own, let's take a look at what this is going to look like programmatically. So I have a code snapshot up of what this would actually look like in a program, guys. So let's imagine we have some Boolean variable called sleepy, and right now it's equal to true. So basically what this is saying in plain English is, hey, if you're sleepy, print go to bed. If you're not, watch one more episode. So let's break this down a little bit further. We have this if keyword here. So this means that our compiler or our program is going to check to see if something is true or false. And then if that thing is true, which is what we're doing here with our comparison operator, we're checking to see if sleepy is equal to true, then we're going to print go to bed. If sleepy is false, then we would print watch one more episode. So this is just a programmatic representation of that decision tree diagram that we saw in the last slide, guys. If this condition is true, then we go down this path. We execute this piece of code. If it is false, we execute this piece of code. So if we had changed sleepy to false, it would skip the if block and it would jump straight to the else block because it would say, hey, you're not sleepy, so you're going to watch one more episode. So it's important to understand that both of these pieces of code cannot get executed, right? We're creating a path, and our program has to choose a path to go down. And it is based on whether or not this condition is true or false. So that's just a brief introduction to how this stuff is going to work and what it's going to look like in the code, guys. We're going to hop into Xcode now to do a bunch of examples and really get some practice with this stuff so that it starts to make more sense and you can see how it's going to be applied in real life programs or applications. So let's go ahead and hop into Xcode now and get started with the code. So to start this off, we are going to create a new playground. So let's hop over here and right click on our project file name, hit new file, and we are going to search for a blank playground, hit next, and we're going to call this control flow, guys. So this is just another way of describing what we're doing here. We're controlling the flow of our program through the use of these if-else statements, or logic gates as they're referred to sometimes. So we're going to start off with a really simple example, and we're just going to break it down piece by piece. There's a couple little nuances that I want to cover in terms of the brackets and how to type this out before we move forward with some more complex examples. So we're going to start off by creating two variables, A and B. We're going to set A equal to 2 and B equal to 3. So what we're going to do is just write a simple program here to check and see if they're equal to each other. And we're going to give back some sort of message or print out some sort of message to give us back the result of whether or not they're equal. So we're just going to say if, and you guys will once again notice that this is a keyword that my compiler recognizes. Now we need to follow this with some sort of condition. So we want to check and see if A and B are equal to each other. So in order to do that, we would say A equals B. And then after that, you're going to open up this curly bracket, guys. And then once you hit enter, your compiler will close out that curly bracket for you. So this is what's known as our if block. So if you guys remember from the overview that we did, this is only going to get executed if this condition is true. So the code we put inside of this if block will get executed if this guy is true. It will go down this path. And then if it's not true, we say else, and we will refer to this as the else block. And whatever code is inside these two brackets will get executed if this condition is not true. And if you guys want to see where one bracket ends, like if you want to see, hey, where does this bracket end? You can just double click on one of your brackets and it will show you where the ending bracket is. So you can see that full block of code. You could imagine if your code starts, if the block is like really long, it would be helpful to be able to see where it ends and everything that's inside that block. So that's just a cool little tip. So basically, guys, all we're going to do is say print A is equal to B. And else, we're just going to print A is not equal to B. And then if you go ahead and run your program by clicking that play button, we're going to get A is not equal to B. So if I went like below my two variable declarations and I said A equals B, you guys will notice that the updated value is now 3. The updated value of A is now 3 because we set A equal to B, and then it gives me back A is equal to B here. So once again, guys, we notice that only one of these blocks can be executed, and that is the point of this control flow here, right? Because we want to force our program to only go down a single path. We're creating like a fork in the road, and it has to pick one or the other. And that is all based on this condition here. And we typically use comparison operators to create these conditions. So really quickly, I'm actually going to paste our notes up here for this module. You guys should pause the video and type this out. So we see here that conditional statements allow us to execute certain blocks of code based on whether or not a given condition is true or false. And we typically use comparison operators for this. So you guys could write all kinds of conditions here. You could say is A greater than or equal to B, is A greater than B, is A less than B, and you could add the corresponding print statements for those results. So that's just a really simple example, guys, of how to use comparison operators to implement a simple if-else statement. So now what I want us to do is implement a Boolean variable like we did with our sleepy guy and going to bed or continuing to watch Netflix. So let's go ahead and create another variable up at the top. We're going to say var sleepy equals true. And we're just going to write out that if statement that we saw in our presentation. Just once again, get some more practice with typing this stuff out and familiarizing ourselves with this. So we're going to say if sleepy, and you can open up your curly brackets. And yes, we do not necessarily have to say equal equals true there. I will explain why in a second. And then we can say else and open up your brackets there. So here we're just going to print go to bed. And here we can print watch one more episode. And let's run this. And we'll notice that we get go to bed. So you guys might be asking yourselves, hey, why didn't you have to use this equal equals true guy to check if sleepy is equal to true? Well, basically, Swift is smart enough to know that we're checking to see if a Boolean variable is true or false. So it basically handles this for you, so you don't have to type it out with Boolean variables, right? Because Boolean variables can only have one of two potential values. So if you're just saying, hey, if sleepy, it's basically saying if sleepy is true. So you don't have to type out that equal equals true guy for Boolean variables. So really quickly, guys, if we change sleepy to false, I got to say sleepy equals false, and rerun our program, we'll notice that it prints out watch one more episode. So just another example of how to use Boolean variables within if statements. And really quick, guys, I just want to touch on this equal equal sign one more time. This is something that beginners get confused with all the time. And they confuse the single equal sign with the double equal sign. So I just want you guys to remember that the single equal sign is an assignment operator. It sets something equal to something else. This is setting A equal to 2. This is setting B equal to 3. And on line 13 here, we're setting A equal to B, right? But with two equal signs, every time you guys see that, I want you to say in your head, is equal to. Okay, so when you see two equal signs, you say if A is equal to B. When you see a single equal sign, you say, hey, I'm setting A equal to 2. I'm setting B equal to 3. I'm setting sleepy equal to true. Or here I'm setting A equal to B. That is very important to understand early on in your programming journey, because like I said, it's something that people get confused with all the time. So just wanted to touch on that. But anyway, guys, let's go ahead and do a slightly more complex example. We can definitely go through some examples of how to make our logic a little bit more complex and a little bit more functional here. So I want us to create a variable called age, and it's going to equal 18. So we are just going to start this off as a very simple if-else statement. Oops, I need to say var age equals 18. Sorry about that. So we're just going to say if age is greater than or equal to 18, print you're an adult. Else print you're a minor. So this is a very simple age checker, right? So if we run our program, we'll notice that we get you're an adult. If I changed my age to 16 and ran it, it would say you're a minor, okay? So I want us to make this a little bit more complex. So basically, what if we wanted to add another sort of pathway here, right? We wanted to check if someone is older than 18, but what if they're older than 65 and that makes them a senior citizen, right? So what you can do is you can actually add something called else if statements. So I could say if and then else if age is greater than or equal to 65, print you're a senior citizen. And let's move this back up here. So this is just showing you an example of how you can introduce multiple pathways into your control flow. So you can say if, else if, else if, else if. You can sort of have an unlimited amount of else if statements, right? Just to introduce more pathways into your logic based on whatever the needs of your program are. So here we're just trying to determine if someone is an adult, if they're a minor, or they're a senior citizen. So something interesting here, guys, which is why I love this example so much, is that this is actually just going to print you're an adult. Oh, sorry, we got to change this back to 18. Or let's actually change it to 65. So we'll notice that this just prints you're an adult, right? So you might think, hey, it should hit this else if block. But once it goes and hits the first if statement, it says, hey, age is 65 and 65 is greater than or equal to 18. So I'm just going to print you're an adult. And then once it hits a particular block or goes down a particular path, it completely ignores all of the other paths. So you might be asking yourself, okay, well, how do we fix this? Well, the simple answer is you would just want to check to see if they're 65 first, and then check to see if they're 18, and then hit your else block and say, hey, everything else is means you're a minor. So if I change these two ages, 65 and 18, you guys would notice that it prints out. Oh, let's switch these print statements up. And I'm going to show you guys a detailed diagram of this to just make more sense of it and help you visualize it in just a second. I just want to get the program working first. So when age is 65, it says you're a senior citizen. If I change age back to, like, let's say 50, it's going to say you're an adult. And then if I change age to like 15, it will say you're a minor. So really quickly, I just want to show you guys a visual breakdown of that so you have a better understanding of how this is working, and we can come back to the code and do some more examples. Okay, guys, so when our code looked like this, age was 65, but we first only checked to see if the user was greater than or 18, we noticed that it just printed out that you're an adult, but we wanted it to print out that you're a senior citizen. And here's why. This is what the visual breakdown of this would look like. So first off, our main condition is we're checking to see if they're over 18, and the age is 65. So 65 is greater than or equal to 18. So it just went down this path and printed out you're an adult. And it completely ignores all of the other paths. So when If it was no, then it would ask if the user was 65 and then say, okay, you're 65, you're a senior citizen. No, you're a minor. So we had to just reorganize our if statement to look like this. So we first check to see if they're over 65, and then we print they're a senior citizen, and then we check to see if they're over 18. So this is what the updated path would look like. Hey, is the age greater than or equal to 65? Yes. Okay, you're a senior citizen. And you guys noticed if we changed the age back to like anything below 65, then it went down the no path, right? And then it checked to see if they were greater than or equal to 18, and then it would print yes, you're an adult. If not, then it would ultimately print no, you're a minor. So that's just a really good example to show you how you can implement multiple pathways in your control flow and how to do it so that you get the correct result, right? You have to think about the first condition that you check, and it's also important to illustrate the concept that once we go down a particular path, it ignores all of the other paths and sort of exits this control flow statement. So let's hop back into Xcode and just do a couple more examples, guys, to really cement our understanding of this stuff. So in this next example, I want us to introduce the concept of logical operators. So what these are going to allow us to do is create compound logical expressions. So what I mean by that is up until this point, we have only been able to check to see if a single condition is true. A logical operator is going to allow us to create a combination of things to check to see if multiple things can be true at once before we execute a certain piece of code. So really quickly, guys, let's just go ahead and do an example to see what the heck I'm talking about. So let's imagine you're trying to write a program to help you figure out if it's a good idea to buy a car or not, or if you're even able to buy the car. So we're going to introduce a couple variables. We're going to look at how much cash we have in the bank, what the price of the car is, and what the current interest rates are. And we can write a program to help us determine if it's a good idea to buy the car or not. So let's go ahead and introduce these variables, and we're going to implement some logical operators into our control flow here to illustrate what I'm talking about in terms of what these are. So we're going to say var total cash, and let's say you got 50 grand. You're balling, right? And then let's say var price of car equals, like, maybe let's make it 40,000. And then let's say var interest rate equals like 0.8. So that's an 8% interest rate. Okay, so let's really quickly just write a simple program here to see if we can afford this car. So basically I could say if total cash is greater than or equal to price of car, and to create this compound expression, guys, this is where this comes in. You're going to implement two ampersand symbols or two and symbols here. So this is going to allow us to check to see if something else is true before we go down this or enter into this if block. And then we could say interest rate is less than or equal to 0.6. Print buy the car. Else print you can't afford it yet, save more money, right? So basically we're checking to see if one, we have enough money to buy the car, but two, we only want our interest rate to be less than or equal to 6%. So currently you guys should be able to ascertain that this would print you can't afford it yet because the interest rate is greater than 6%. So let's print this out or run our program. It says you can't afford it yet. You need to save more money. But if we were to change the interest rate to like 0.5, it would say buy the car. So basically, guys, what we did here was introduce this logical operator here. And this is what's known as an and condition. So if you imagine that this piece of logic here is condition A, and this piece of logic here is condition B, both A and B have to be true in order for this if block to execute. So we also have an or condition that we can use. So I could say two up and down lines like this, and you guys could just hold the shift key and hit the backslash button, I believe it is, or /, one of the two, you'll find it. But basically this would say if this is A and this is B, only one of the things has to be true in order for my entire expression to evaluate to true. So you guys would notice if I change this back to like 0.1, meaning like a 10% interest rate or 8 for 8%, and I ran my code, it would say, hey, you can still buy the car because you have more cash. So in order for an OR statement to evaluate to false, both A and B have to be false. So if I change the price of the car to $60,000 and the interest rate was 8%, it would say, hey, you can't afford this yet. So I'm just going to bring up a quick table here for you guys to see exactly what this looks like. So let me make this bigger for you. So basically, guys, if you have A and B, in order for A and B to be true, both things have to be true. You notice if A is true and B is false, then the condition evaluates to false. But A or B still evaluates to true. And then if A is false and B is true, this is false, but A or B is still true because one of the things is true. And then the only way that A or B evaluates to false is if both A and B is false. And then we have the not logical operator as well. So here, it's just the opposite of whatever A is in this case. So if A is true, then not A is false, obviously, right? So let's just do one more example here, guys, to really cement our understanding of this stuff. So, and then we're gonna, that'll be it for this video. So let's imagine that you have a tired and hungry girlfriend, right? You're in trouble here. So let's make two Boolean properties for that. So we could say var girlfriend is hungry equals true, and var girlfriend is tired equals true. So we want to write a program to see how much trouble we're in with our girlfriend. Okay, so we're going to say if girlfriend is tired and girlfriend is hungry, then your life might look something like this.
All I want is Wingstop!
That's a little excessive.
Fucking why? I'm fucking starving, Swin! What did you eat today? I ate nothing! Nothing!
So yeah, that would be really bad. Really bad. So we're going to go ahead here and we're just going to say print state of emergency. Everybody run for their lives because you're in danger. Okay, you're in serious danger there. And else we can just say print you're okay for now. For now. So if we run this program, guys, we're going to notice that we're in a state of emergency and that everybody should run for their lives and be very afraid because someone has a tired and hungry girlfriend. So let's think about it like this. If we make girlfriend is hungry, we could consider that to be condition A and girlfriend is tired to be condition B. So this gets treated as like a single expression now. It's just a compound expression. So in order for this to be true, both A and B have to be true. So if I make one of them false, you guys will notice that we're okay for now, right? It hits the else block because in order for this expression to evaluate to true, both A and B have to be true. If either one of them is false, this expression evaluates to false and it ultimately reroutes our program into the else block or else path. So if I had changed this to or, only one of A or B has to be true. Either A or B can be true in order for this overall expression to evaluate the true and ultimately hit my if block. So if I run this now, you guys are going to notice that once again, we should run for our lives. So I guess it really just depends on how your girlfriend is when she's hungry or tired. So these are just some examples to show you guys how we can use logical operators to create compound expressions and introduce some more complex logic into our programs. And that's going to wrap it up for this video, guys, on control flow. Hope you enjoyed it. We'll see you in the next one. Thanks so much for watching. Peace out. In this section, guys, we're going to be diving into data structures and we're going to be covering something called arrays. So let's go ahead and get started with what they are. All right, guys, so what exactly is an array? So it's an ordered list that stores values of the same type. So think of it as a collection or list or like a grouping of data, right? And we use lists in our everyday life all the time. Like when you make a to-do list or a grocery store list, or you use a shopping cart when you're checking out online. These are all examples of arrays. And we're just going to go through some of these examples to talk more about what they are and what their functionalities are and how we're going to be using them. So first up, we have this shopping cart, guys. So think of the shopping cart as your array. It's like a structure that's going to hold a bunch of items that you're about to buy, right? And some of the actions that you can perform on that structure might be what? You might be able to add things to your shopping cart, or remove things from that shopping cart, or apply a discount to a certain item in your shopping cart. And then you might want to get the total of all the items in your shopping cart before you check out, right? So here, the shopping cart is like the array. It's the structure in which we store all of that data. Next up, something very similar, we might have like an expenses list or program that keeps track of all of our daily expenses. And some of the functionality associated with that's pretty similar to the shopping cart. You might want to see the total of all your expenses for that month. So think of that expenses list as the array here. And then, lastly, we have like a to-do list. So think of the to-do list as your array, where you store a bunch of items that you have to do for like that day, essentially. And you can check items off that list or add items to that list, remove them from the list, so on and so forth. So that's what arrays are going to be in programs and applications. And I want us to now go over how exactly that's going to look in the code before we jump into it. And below we see a couple different examples of what arrays or lists, same thing, might look like in real life applications and programs. So first up, we have a shopping cart, right? This might just contain a list of items that you want to buy. We use an array to create that list of items that we can ultimately update as we go, right? We can add things to it or remove things from it, and then ultimately like check out at the end, and it'll give us like a total of the cost of all the items that we want to buy. Next up is like an array of expenses or a list of expenses, right? Once again, you might want to see the total of your expenses for that month. Or you might want to look at the most expensive item in that expenses array, the cheapest item, so on and so forth. We use arrays to create that list and add things to it and perform actions on it, like getting the total and things like that. And then next up, we have something like a to-do list, right? This is something that we can, create a list of items of things we have to do. We can update that list by saying, hey, this thing is done, or, update the due date for this item, add something to the list, remove something from the list, so on and so forth. So these are all real life examples of what we might use arrays for in real life programs. So next up, let's go ahead and take a look at what it looks like to create arrays. So first up, we see we can create an array by initializing it with values. Each item in that array is separated by a comma, creating an ordered list. And we can also create blank arrays and modify them later. So here's what that's going to look like in the code. Okay, so you guys can see here that we're creating these things as variables, and then we name it, very similar to what we did in our variables and constants video. And we're going to use these square brackets to create an array. And we'll come back to this example in a little bit. I want to hop into these shopping cart and expenses examples. So here we have a shopping cart, and we're giving it these square brackets, and we're populating that list with these items. And as you guys can see here, each item is separated by a comma. That's how your computer knows where one list item is versus the next, right? So in a list, you obviously want to be able to tell where things are, and we have to separate each list item with a comma. So this is a particular array of strings, right? And we are giving this array values to start off with, or initializing it with values, as we see in our first point here. Same thing with our expenses array. We're initializing it with numbers. Here we're initializing this with strings. And an important point to note here, guys, is that arrays cannot mix data types. So you can't have a mix of strings and numbers in one array. So that brings me to my next point with this to-do list guy. So when would we want to create a blank array? And why is this like have string in it? And what are these parentheses and all that stuff? So let's go over that now before we hop into the code. So if you think about going to an online shopping site with a shopping cart, does that shopping cart start off with things inside of it? No, right? It starts off as empty, and then you add things to it or remove things from it. So that's an example of when you might want to create a blank array. The only thing we have to do when we create a blank array is supply it with the data type that it's going to be populated with. So we're saying that, hey, this to-do list guy has to be an array of strings. So that's just an example of when you would want to create a blank array. And once again, we use these square brackets, and we just put string inside of it, which is the data type. And then these constructors here, these parentheses, don't worry about that too much. That essentially just creates that blank array for us, but we'll go over that in the code. So Just a quick wrap up of these 3 points, guys. We can create an array by initializing it with values, like we see here with the shopping cart and expenses. Each item separated by a comma, creating an ordered list. And we can also create blank arrays and modify them later, which is what we see in this to-do list item. So now that we've done that, let's just go and hop into the code and create some arrays before we move on to some of the more fancy stuff with like how to modify and update our arrays and perform actions on them and stuff like that. So let's go ahead and open Xcode back up, guys, and let's go ahead and create another playground for our arrays module here. So I'm going to go ahead and hit Command N, and we're going to search for a blank file once again, hit next, and we're going to call this arrays. Okay, so let's just go ahead and start off by creating some arrays here, and let's create our mark really quick, creating arrays, and let's go ahead and just make a shopping cart guy, and we're going to initialize this as a blank array. So this is what it should look like, guys. So once again, you just state that this is going to be a variable. Why does it need to be a variable? Well, ultimately, we're going to want to modify this at some point, right? We're going to want to add things to it or remove things from it. And if it's a constant, you can't do that. Here's where we name it, and then we open up a square bracket, say that it's going to be populated with strings, and once again, these two parentheses actually create the thing for us. I know that might be confusing right now. Don't really worry about that, but if you were to remove that, your program would throw an error, okay? And it said it's expected member name or constructor call, which is what we're looking for there. So this indicates to our compiler to actually create that thing. And like I said, if that's confusing, don't worry. Next up, let's create another array for something like names. Here, let's do some F1 drivers. Let's say like Lewis Hamilton. And then we're going to put a comma, and make sure you put the comma after the quotes, okay? And then I like to do a space, and then we can say Charles Leclerc, or Leclerc, however the hell you say that guy's name. And then let's maybe do like Max Verstappen as well. Don't judge me on who I like in F1. We're not here to talk about that. But let's talk about the differences between these two things. So why do we not need the parentheses here, right? Well, that's because we're supplying this array with values to start off with, or we are initializing it with values. So if you don't give an array values to start with, then you have to apply this constructor. If you do give the array values to start off with, like we're doing here, then you don't have to do that. So basically, guys, these are both arrays of strings, but in this example, we are initializing it with data. Okay, and then let's make one more for something like prices. And then we can just say equals like 24, 12, 35, and like $500 or something, right? So this is just an array of numbers, and it denotes like prices of potential items that we want to buy or something, okay? So next up, guys, this is pretty straightforward. I want us to go over how we can actually like modify our arrays and access individual items in my array. So for example, what do I mean by access? Well, let's say I wanted to grab the first item in my array and say, hey, Lewis Hamilton drives for Mercedes. And then let's say I wanted to look at the second item and say, hey, Charles Leclerc drives for Ferrari, even though that might switch soon, I heard, but irrelevant. And then Max Verstappen is the last item in the array, and we want to say he drives for Red Bull. Or what if I want to remove one of these drivers from here? Or what if I want to add another driver? That's what we're going to go over how to do next. So I want to give you guys a visual representation of what this stuff is going to look like. First off, I want to talk about what it means to access an array item. So each value in an array is assigned an index. And if you think about it, that makes sense, right? Like in a list, you want to have an index associated with each item, meaning like, hey, this is the first item, this is the second item, the third item, fourth, and so on and so forth, so that you can access those items as you go. In programming, this is something that throws a lot of people off at first, but the index or the counting always begins at 0. So the first item in the array has an index of 0. The second item has an index of 1. The third item has an index of 2. Why exactly they do that, I'm not sure, but that's how almost every single programming language is. Indexing or counting always begins at 0. So if I want to access the first item in my array, I would go and look at the 0 index. The second item, I would look at the 1 index. The third item, I would look at the 2 index. So that's how we access array items, guys. Next up, we have modifying arrays. So we can add or remove items from them. And that's what this is going to look like. So if we append something, it adds it to a list. And then if we remove something, it will remove it from that list. So I'm going to show you that one more time. This right here represents what it's going to look like in the code. And this is going to be a visual representation of the array. So let's go ahead and see this one more time. So if we have this array to start, right, just MacBook Pro and AirPods Pro, and then we execute this command, shoppingcart.append GoPro, it's going to add an item to my list, just like that. And then if I have that same array and I call shoppingcart.remove at 2, right, it's going to say, hey, I'm going to remove the item at index 2, and then it will just remove that guy like so. So this is what we're going to be doing in the code next, guys. We're going to go over how to access items in the array and how to modify our arrays. So really quick, let's hop back into Xcode and let's go ahead and create another section. And we're going to say access and modification here. And the first thing I want us to do, guys, is go ahead and see if we can add an item to our shopping cart. So let's just go ahead. Oops, my bad. Let's go ahead and say shoppingcart.append. And you guys will see that that comes up in our autocomplete window and it says adds a new element at the end of the array. So this adds an item to the very end of the list. We're going to go over how to add something at the beginning of the list or anywhere in the list that we want in just a little bit. So here you guys notice that it says give me a new element and that it has to be a string because it recognizes that when we created it, we said that this has to be an array of strings. So here we can just go and say MacBook Pro. And let's go ahead and just hit play right there and pay attention to what's happening over here, guys. So you guys notice that up here, my shopping cart has 0 elements. My names guy has 3 elements. My prices guy has 4. And now shopping cart has 1 element inside of it and it's MacBook Pro. Okay. So then we can also say, like, if we want to add another item to it, shoppingcart.append AirPods Pro. Hit play. And now it has 2 elements and you see that it added that item to the very end of the list there, right? Okay, so next up, let's go over how to access items inside of our arrays. And then we'll go over some of the other modification operations like removing and inserting and stuff like that. So like I said, guys, imagine I wanted to get a certain item, like individual item from this array. How do we do that? So I could say let like driver1 equal names and then open up my square bracket and then pass in 0. Okay. So this is how we access something. So basically we're saying we're going to store this thing in a property and I want you to give me back what is at the 0 index in the names array. So this should give me back Lewis Hamilton. Let's go ahead and run this and we see here that it gives me back Lewis Hamilton. Then I could say let driver2 equal names 1. And as you guys might be able to guess, this is going to give me back Charles Leclerc. Charles Leclerc. And then if I want to get driver3, you guys should be able to get this by now. We would say names 2. So this is accessing individual items in our array, guys. We just state the array name here, and then we open up our square brackets and we pass in an index. However, if you were to try to say like driver4 equal names 3, your program would crash, unfortunately, because there is no 4th item or item at the third index or 3 index in my array. So we have to be careful with how we access items in our arrays, and there's much safer ways of doing this, and we will see that later on as we go. So make sure that you don't get this error here. Let's go ahead and delete that. And once again, guys, that was happening because that item doesn't exist. There's only 3 items inside of this array. So trying to get names 3 would say, hey, get me the 4th item, but there is no 4th item, so our program crashes. Okay, so actually let's keep that there and comment it out by just hitting Command/, and say, this will cause crash, index out of bounds. So that's what the crash would say. The index you've given me is out of bounds. So next up, let's go over how we can remove some items from our array. So let's say like names.remove at 2. So you guys will notice that this guy is saying, hey, you have to give me an index that you want me to remove the thing from. Okay, so if I hit play here, you guys will notice that this gives me back Max Verstappen because that's the thing that it removed. But if I were to go ahead here and just say names or print names, whatever you want to do, it now only has 2 elements inside of it, okay? Lewis Hamilton and Charles Leclerc. So let's go ahead and see if we can do that with our prices as well. We could say like prices.remove at 1. And that would give me back 12. But if I go ahead and just type prices out, we can see the updated list. So the reason that's giving me back 12 is because that's what it removed. But now it only has 3 elements inside of it. And it's 24, 35, and 500. Okay, next up, guys, let's go over how we can insert items at anywhere we want to in the array, right? Because if you think about it, what if you want to add something to an array, but you want to add it at a certain spot, right? Like you want to add it in the first spot, or you want to add it somewhere in the middle. Append is only going to add something to the end. So there is another operation we can perform to add something anywhere we want to in the array. So here I could say like names.insert, and it's going to give me 2 items that I have to pass in to this function here, or this operation. It's going to say inserts a new element at the specified position. So basically this function, or this operation here, is saying, hey, what's the item you want to add and where do you want to add it? So here I could say like, Checo Perez, another F1 driver, and then I want to add him at 0. This is going to add Checo at the first index. So inserts item at beginning of array. And let's just go ahead and run this, guys. Okay, so now you'll notice my array is Checo Perez, Lewis Hamilton, and Charles Leclerc. And Max Verstappen is still gone because we removed him here. So let me add another comment, removes item at specified index. Okay, and then, that works the same way if you want to insert, like an item anywhere in the array. So you could insert it at the 1 index, the 2 index. The only requirement is the index remain in bounds, okay? And if you want to just add it to the end, then you use append. So let's add another note there. Adds item at end of list. Perfect. And then we have some other commands, guys. Like we could say prices dot remove first. And that will just remove the first item in the array. And you can also say prices.remove last. And that will remove the last item in the array. So these are all just pretty basic examples of operations that we can perform on our arrays. And they should all make sense, right? These are things we do in real life programs and applications every day. When we remove things from a list, or we add things to a list, or we say, hey, get me this item and maybe perform a discount code on it, or go in my to-do list, look at item 3 and check that off my list, right? So this is how we accomplish those simple operations and perform operations on lists of data in our programs. So next up, guys, I want us to talk about another type of data structure. It's going to be a dictionary, and it's going to have certain capabilities that arrays do not, but they're going to be pretty much the same, just different. Same, but different, if you know what I mean. So let's go ahead and take a look at what dictionaries are going to look like, and then that's going to wrap it up for our data structures fundamentals. So we'll see you guys there. What's going on, guys? Welcome back. Hope you are doing well. In this module, we're going to be talking about dictionaries. So it's another type of data structure, very similar to arrays in that it's a list of data. The only difference here is that dictionaries are a set of key value pairs, as opposed to arrays where each individual item is a singular value. Each individual item in a dictionary is a key value pair. So what exactly is that going to look like? Here's an example. So we can see that the indexing system is exactly the same with arrays, right? So at the 0 index, this is our first item. The only difference with a dictionary is that each item, like I said before, is a key value pair. So what is this example that we see here in front of us? It's like a social security system, right? So this would be a dictionary where all of the keys are social security numbers and all of the associated values are people's names. So we would use the social security number as a lookup tool to find out who the person's associated with that social security number is. So I'm sure you guys have had to do that at some point, right? You're on the phone with your bank. They say, hey, give us your phone number or the last 4 of your social so that we can find out who you are and verify your identity, right? You use dictionaries to do that. Another example would be this like stock ticker symbol system where each company that is publicly traded on a stock market has an associated ticker, and then you have an associated price with that key. So for example, Tesla would be $200. Apple is $143, whatever it is. You could also associate this key with the company's name. So TSLA is obviously Tesla, AAPL is obviously Apple, GOOG is obviously Google. So let's go to the next point, guys, where all keys in dictionaries have to be unique. Okay, so you can imagine things would get really messy and confusing if 2 people had the same social security number, right? You wouldn't be able to tell who's who. That's why your social security number is a unique identifier for who you are. So when someone goes to look up who you are, it doesn't give them back 10 different people. It's associated with a single person. Same with stocks, right? You can't have duplicate ticker symbols because then you wouldn't know which company's which. So in dictionaries, all keys have to be unique. And this brings me to my next point, which states that dictionaries are a significantly more efficient lookup tool than arrays, since we can associate a value with a unique key as opposed to just trying to find something with a random index. And we'll dive deeper into that point once we hop into the code. Let's go ahead and take a look at what it looks like to create a dictionary. So just like arrays, we can create a blank dictionaries or initialize them with values. So this is what dictionaries look like programmatically. So each item is also separated by a comma, just like arrays, and we use a colon to differentiate the key and the value. So in this case, guys, we create our variables here just like we did with arrays, but we can see here that each individual item, like the comma separates one between the other, is this key and value pair. So if we look at this guy, we use a colon to differentiate the key and the value. What comes before the colon is the key. What comes after is the value. So here we have a name to email dictionary where we're associating a name with an email. Then here we have a name to age dictionary where we're associating a name with some sort of age for a person. And then this is a blank dictionary where we're just stating that, hey, all of the keys have to be strings and all of the values have to be doubles or a number type. It could be integers, whatever it may be. So this is an example of a string to string dictionary. All keys are strings, all values are strings. This is an example of a string to int or number dictionary. All keys are strings, all values are integers. And then here, this is a blank dictionary that states that, hey, all the keys have to be strings, all the values have to be doubles. And then just like arrays, we use our constructor to create that guy. So now that we've gone over what these are and how to create them, once again, let's hop back into the code and go over how we can create some dictionaries of our own. All right, boys and girls, let's hop back into Xcode and let's create a new playground for our dictionaries. So it's going to be a blank playground, and we're going to call this guy Dictionaries. Dictionaries. There we go. Cool. Okay, so let's create a mark here to go over how to create our dictionaries. Spelled that wrong. Give me 1 second, guys. Dictionaries. Okay, cool. All right, so let's go ahead and create this name to email dict, and we're going to open up square brackets just like we did with our arrays, and we're going to say John is the key, and then you're going to put a colon after the the parentheses, and you're just going to say like johndoe@gmail.com. So this is an example of how to create a dictionary and initialize it with values. And if we want to add another one, you put a comma after this key value pair, And then, you can just create another one like tomlong@gmail.com, something like that. Who knows, who cares? So this is a dictionary with initial values. And if we want to create a blank dictionary, we could go here and just say, hey, this is a dictionary that's going to be something that where all the keys are strings and all of the values are strings. And then we use this constructor to create it. Okay, and then another example is we could create like name to age dict and say that, hey, John is 32 years old, Tom is 24 years old, something like that. So we're initializing it with values. We just have a different key and value system. So keys can be anything you want, values can be anything you want. You just have to keep them consistent throughout the your whole dictionary process. Okay, so let's go over how to actually look things up in a dictionary now, right? So you guys still might be unclear for to the purpose of these things and why they're more beneficial than arrays in some situations. So we're going to go over how to actually use them now. So let's go ahead and add another section for our dictionary lookups. So what if I wanted to look up, John's email? So I could say let John email equal name to email dict, and then I just have to pass in my key, John, and make sure the capitalization matches up, guys. And let's go ahead and run this and see what it gives me back. So I get back johndoe@gmail.com. So this is how I get the associated value with my key. So the way you're supposed to really structure your dictionaries, guys, is whatever you want to use as your lookup tool or parameter, that's what you make the keys. And then the values are what you want to find out based on the keys. And you could have done that the other way around as well, right? Like you could have made the email the key and the value the name. It really just depends on what you want your dictionary to be used for. Just know that the keys are what you are used as the lookup tool to find the associated value. So let's just do another example here. Let's see if we can get Tom's age. So we could say let Tom age equal name to age dict and pass in Tom. So what this is doing, guys, just to clarify, is that the dictionary is going through and trying to find this key Tom, and then it's giving you back the associated value. So that's why we see 24, because Tom is 24 there. Okay, so now that we've gone over how to look stuff up in dictionaries, let's go and see if we can update things in dictionaries. Like let's say John changed his email, right? So let's make a mark for updating dictionaries. So if we want to go back to that example I just talked about where we want to update someone's email, say you have an app and John just changed his email, then you could say name to email dict, and then you go and find John, right? That's what this does. Then you could say equals johndoe@yahoo.com. And then we could just go ahead and print out our name to email dict, and it'll come up here. And guys, we can see that we have updated John's email to johndoe@yahoo.com, whereas up here it was johndoe@gmail.com. So this is just how you update something. You go and find the key, and then if you say equals, it's going to update the associated value with that key. So, all right, guys, what is the benefit of dictionaries to arrays here? Well, let's hop back into our arrays guy really quickly, and let's imagine that I wanted to find someone in this array or find out some information about them, like who they drive for, right? The only way we have for accessing things in this arrays is using these index values, right? So I have no idea who's at these spots in my array. Like in this situation, it's really easy because I made the array and populated it with names, but anybody could be at index 0. Anybody could be at index 1. Anybody could be at index 2, right? So dictionaries give us a much more efficient way of looking things up, right? So if I wanted to, for example, like I said, find out who Lewis Hamilton drove for, I could just have a dictionary that associates driver and a team name. And then I could look up that driver in the dictionary and it would automatically give me back their team name. Whereas with an array, I would have to go through each individual item to try to find that, right? I'd have to say like, hey, go to item 0. And if it equals Lewis Hamilton, then give me back the team name or whatever it might be, right? So that's the benefit of dictionaries over arrays. They each have their own individual use cases. And as we get into more examples with fundamentals here, we're going to see when to use one and when to use the other. This right now is just exposure for you guys to see what an array is and what a dictionary is and what the differences between them are and what the benefits of each one are and what the use cases for each one are. Once we get into creating our own programs and applications, we'll see exactly when to use one or the other and the benefits and drawbacks in each situation. So that's just a really quick breakdown of dictionaries, guys. Let's go ahead and move on to the next module now. Thanks for watching this one. Peace. What's going on, guys? Welcome back. Hope you're doing well. In this video, we're going to be talking about the concept of loops in computer programs. So let's go ahead and take a look at a definition. It's an instruction that continually repeats until we want it to stop. So essentially, this can help us perform tasks repeatedly more efficiently, leveraging the power of computers, right? And we can also use this to iterate through data structures like arrays and dictionaries. And we'll see examples of all of these things once we hop into the code. Before we do that, I want to give you guys some real life examples of loops so that we can better understand the concept. First off, let's imagine a teacher that's grading a stack of tests, right? She has to go through each individual test and perform the same operation on each one. She has to grade each test. She starts at the beginning and ends when she gets to the last test. So she repeatedly performs the same task over and over again. And you can imagine how a computer could do that much faster than a human being, right? Imagine you stick that into a computer. The computer could probably grade 30 tests in a matter of seconds, where a person might take hours to do that, okay? Another example would be like a washing machine. So imagine you got a pile of dirty clothes that you want to wash. You put them into your washing machine, select the desired cycle, and let it do its thing. The washing machine is going to repeatedly agitate those clothes over and over again until it's, ready to stop and the clothes are clean. In this case, the washing machine is the loop and the clothes are the tasks you want to perform repeatedly. Another example would be like someone stuck in a time loop, right? Imagine they are continually repeating the same day over and over again. At minute 0, they start their day. At at hour 24, the day starts all over again. And then they just keep going and going and going. And hopefully at some point that loop breaks and the person stops being in the time loop, right? But essentially the key here is repetition. So let's go ahead and talk about the first type of loop we're going to be working with of 2 types, okay? We're going to be working with something called for loops and while loops. We're going to start off with for loops. So basically a for loop runs a set number of times before stopping. We define a range with an upper and lower bound to determine the start and end points of this loop. So if we go back to our example of the teacher grading papers, she starts at paper 1, and if there's 30 kids in the class, she stops at paper 30 or test 30. So we have to define the start and end points of our loop. The number of times the loop will run is the upper bound minus the lower bound. So pretty simple. If the teacher has to grade 30 tests, the loop is going to go from 1 to 30. That loop will run 30 times. So this is what the loop is going to look like in our code, guys. So there's a lot to unpack here. Let's go ahead and get started. So in this case, the I represents the iteration of the loop we are on. It begins at the lower bound and increments by 1 after each iteration of the loop completes. This repeats until we reach the upper bound. So in this case, this 1 through 10, 1 ... 10 represents our range of values. We're going to go from 1 to 10. Inclusively, right? So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times this loop will run. At each iteration, this I guy represents the iteration of the loop we are on. So first off, it's going to be 1. And it's going to perform whatever code we put inside of these blocks. And then once it gets to the end of that block, it's going to go and repeat again. And then I will be 2. And then after it runs the code, I will be 3, 4, 5, until it gets all the way up to 10 and stops. So this is a visual representation of how these loops will work. So basically, while the loop is running, it's going to ask, are we at the last item in the range? No. Okay, continue loop and execute code. And then it's going to go and ask that question again until it gets to the last item where it says yes, and then it's going to exit our loop. So that's a visual representation of what a for loop is going to look like, guys. Let's go ahead and hop into Xcode now and do some examples of our own and see how powerful loops can be. So with Xcode opened up, guys, let's go ahead and create yet another playground here. So blank playground next, and we are going to call this loops. So let me go ahead and paste my notes in here. So this is just what we had in our presentation, and let me go ahead and paste another section here for our for loops. So like I said, we're going to be going over two different types of loops, for loops and while loops, and I'll explain while loops in a little bit, obviously in part 2 of this module, but we're going to be looking at for loops first. So let's go ahead and look at an example of a for loop and see how powerful this can be. So let's go ahead and say for I in 1 ... 10 and open up your brackets here. And then let's just go ahead and say print I and run our code. So we can see here that this will instantly print 1 through 10. So what's the alternative we would have to go through to accomplish that same effect, guys? I would have to say print 1, print 2, print 3, so on and so forth. So that would take me 10 lines of code to do what this is doing in 3 lines of code, right? So here is a very clear example of where we can see the power of loops, and we can really leverage the computing power that computers have nowadays. So, if I wanted to go 1 through 100, let's see how fast this prints me out 1 through 100. Pretty much instantly, right? All the way from 1 to 100 in our console. And let me just go through a breakdown of this one more time for those of you who still might be confused. So in our for loop, we have to define a range. Okay, so this is our range. We're going from 1 all the way up to 100 with this ... And I'll explain what this means in a little bit too. And then the I here represents the iteration of the loop we're on. It starts at the lower bound and goes all the way up to my upper bound, which is why we get back these numbers here. It starts at 1, and then on the next iteration it's 2, the next iteration it's 3, 4, so on and so forth until we get to 100. So basically what's happening inside of these blocks or these brackets is what my loop is doing 100 times. So I could add in any code that I want here. Okay, I could say print hello, and it would print hello out 100 times. Okay, so it doesn't we don't necessarily have to use this index. You can see that we're getting a warning here, but we can see here that we can just use this loop to perform a task a repeated number of times very efficiently. So we can go more into what this index guy is in a little bit. We don't always need it. We can just do this to print out anything we want. So if we never actually use it, we can just replace that with an underscore. And that just says, hey, run this thing 100 times. I don't care about the index. I just want to perform some task 100 times. But if I want access to the index, then I want to say print I. Then we're actually using that guy. And there's certain situations in which you want to use it and some which you don't, which we'll go over once we do some more examples. So next up, guys, I want us to go over some different ways of defining ranges, okay? So I want us to, add a print statement here and just add a bunch of lines to create some separation in our program or our console. And let's create another for loop. I want to say for I in 0 up to, but not including 10. So this is just another way of defining a range. I can say print I. Oops, not quotes. That would just print I. It's like I is a string. We want to print this index here. And let's run this and see what that does. Oops, let's make that 10 again. We don't need it to be 100. Okay, so you can see here, guys, that the loop runs the same number of times. Okay, these loops are both running 10 times, but here we just defined a different range. We're going to go over when you might want to use one versus the other. But essentially, if you say ... it goes up to and including that number. If you say ... but less than, it doesn't actually get up to 10. It goes up to 9. And the reason these run the same amount of times is because here we're starting at 0 and going up to 9. So 0 to 9 is the same as 1 to 10. And you guys can see here the difference in the print statements, right? This starts at 0 and goes all the way up to 9. This starts at 1 and goes all the way up to and including 10. If I were to change this to a less than sign, this would now print 1 through 9, and this loop would actually only run 9 times as opposed to 10. So that's just some different ways of defining ranges, guys. And let's grab this guy here and put it below here. And let me just write out an example one more time of what it looks like if you just want to run a piece of code X amount of times. We could say, 0 up to and not including 10, print hello there. And if we run this, it will just print hello there, 10 times. And we don't particularly need the index property there. This loop will just run 10 times. We never need to use this I guide to get access to the iteration of the loop we're on or the value of the range. So we can just use an underscore there. Okay, so now that we've done that, let's go over how we can now iterate through data structures and the purpose of that. This is probably the most common reason for looping or using loops in programming is actually iterating through data structures. So let's go over that now, guys. So as I stated, we can also use loops to iterate through data structures like arrays or dictionaries. This is extremely helpful for things like searching lists or modifying elements within a list. So the loop will start at the beginning of the array and stop when it reaches the end. So this is what it's going to look like programmatically. So imagine we have a shopping cart array. The structure of the loop remains the same, where we say for something in something else, and then we can print this right here. And you guys might be able to guess this would just print each item in the array. So it would print item name is MacBook Pro, item name is AirPods Pro, item name is GoPro. So let's go over a visual representation of what that's going to look like. So it's going to start at index 0 and then go to 1 and then go to 2 and then it's going to end. So let me just do that one more time. So the loop starts at 0 and it will execute the code in the block, which is just printing out the name of that item. And then there's no more code left, so it's going to go to the next iteration. And then I is going to equal 1 at that point. And then it's going to print item name is AirPods Pro, and then it's going to go to I equals 2, item name is GoPro, and then the loop will recognize that there are no items left in the array, and we are going to then exit the loop. So let's hop back into Xcode now and actually write out these examples that we just went over. So go ahead and just add another divider after this guy right here, and let's create our shopping cart array. And it's going to equal, MacBook Pro, AirPods Pro, and maybe like an iPad Pro or something, right? And like I said before, the structure of the loop is the same. So we can say for item in shopping cart and just open up your brackets and say print item name is item. So let's run this and then we'll do a line by line breakdown of what's going on in the code. So guys, we can see here that item name is MacBook Pro, item name is AirPods Pro, item name is iPad Pro. So that's exactly what we expect, right? Based on the diagram that we just saw. So the loop is going to start here at the first item. It's going to execute this line of code, and then there's no more code left. So it's going to go to the next guy, execute that line of code where item name is going to be AirPods Pro, go to the next guy, item name is iPad Pro, and then it recognizes that there's nothing left in the array. So the loop stops there. So let's talk about this notation that we have here and how it's different from what we saw here. So before, we were creating a range of values, right? Where we're saying, hey, loop through this range of numbers. And in this case, the parameter name that we have here, I, is going to represent a number or an index value. So that when we say print I, this prints 1 through 10. This prints 0 through 9. And this, we don't need I, this just runs 10 times, right? But the key here is that we were defining a range of values and telling the loop when to start and when to stop. Lucky for us, Swift is smart enough to know that we are looping through an array, and it knows exactly when to start and when to stop. So we don't have to explicitly define that range of values. Swift just knows to do that because you're looping through an array. And in this case, the parameter name doesn't represent an index or a number. It represents the item at each particular spot in that array that we're looping through. So in this case, item represents MacBook Pro on the first iteration, this guy on the second iteration, and iPad Pro on the third iteration, right? So you guys can call this whatever you want. You could say for X in shopping cart, print X, and it will do the same thing. This parameter name, you just get to name whatever you want. Up here, we were doing it as I because that's pretty much standard naming convention for when you're looping through a range of values in programming. You could say for I, for index, for IDX for short, doesn't matter. Key here is that you can name this whatever you want, but it should make sense based on what you are looping through. So let's just go ahead and do another example, guys. Let's create like a prices array. 10, 20, 30, 40. And let's go ahead and just say for price in prices. And then let's go ahead and say print price is, and use some string interpolation there like we did before in that module there. Print out our price. And let's go ahead and get another divider in here. And you guys notice my compiler is giving me an error now because it says, hey, we don't recognize X. It has to be item. Just like that. All right, let's go ahead and run this bad boy. And we just get prices 10, 20, 30, 40. Okay. Now what I want us to do, instead of just printing out stuff, I want us to go through like a real life example of something you might use a computer program to do with something like a shopping cart or when you see a list of prices. Let's imagine that we have some coupon that we want to apply to all of our prices and give the user a list of the updated prices after they apply that coupon, right? So let's imagine they have a $5 or a $10 coupon for each item. So let's just go ahead and create another property here. We can say let coupon price equal 5, okay? And now we can go through and say print price with coupon is price minus coupon price, just like that. So this is going to just give each item a $5 discount. So let's go ahead and print that out. And now we can see all of the updated prices with our coupon. And if we were to change this to like, let's say, $10 and run this again, obviously it would just give us the updated list of prices with that $10 coupon. So that's a real world example of what you might actually use a loop to do, guys. And you can imagine that if that had 1,000 items in it, like if that's for a company or a grocery store or something like that, and you want to apply some sort of operation to it, a loop is going to be exactly what you want to do that, because it's going to be able to perform that operation significantly more efficiently than we can writing things out line by line or doing things in a non-programmatic way, like manually by hand or something like that. So another example I want us to go over before we hop into our next section with loops, with while loops, is one more way of looping through an array. So we can say for I in 0 up to, but not including, prices.count. Okay. Then what I'm going to do is say let price equal prices I, and print price is price. And let me get my divider in here. And I know that might be a little confusing, guys, but I want us to just run this and see what happens. And we can see here that it just prints out all of the prices in our prices array. So let's go over how this works really quickly, and then we're going to go over the difference between these two things. So they are essentially doing the same thing, but this is going to give us a little bit more capability and functionality, as we're going to see here in a little bit. So guys, this is looping through a range of numbers the same way we are up here. So we're starting at 0, and then we're going up to, but not including prices.count. So let's break that down. So we see that prices has 4 values inside of it, and this loop runs 4 times. But if you guys remember, programming counting is 0 indexed, or it starts at 0 and it goes from there. So This is something that's a little annoying to have to deal with, but it is what it is. That's just what we have to deal with as programmers, is that prices.count is going to equal 4. But you guys would notice if I try to access index 4 in this array, it would be out of bounds. Like it would be right here, right? This is 0, 1, 2, 3. So we can't access index 4 in this array. So that's why we have to go from 0 up to, but not including prices.count. So this is going to go 0, 1, 2, 3. Okay. And then it's going to stop at 3 because that's where our array needs to end. So here we're looking at an index value. So let me just add something to our print statement really quick. Index is I, and let's run this one more time. So you guys might be able to start slowly putting this together. The price is 10 when the index is 0, price is 20 when the index is 1, price is 30 when the index is 2, so on and so forth. So if you guys remember back from our arrays module, how do we access items within an array? Well, we just have the array name and then we use our brackets and we pass in an index, right? So in this case, name 0 is Lewis Hamilton, names 1 is Charles Leclerc, names 2 is Max Verstappen. So that's exactly what we're doing here. We're just using a loop to accomplish that, right? So when we say let price equal price is I, on the first iteration of the loop, when the index is 0, it's going to say, hey, go and get me prices at the price at the 0 index from this prices array. And then it's going to store it in this value, and then we are printing it out there. So this is bringing together a lot of the concepts we have previously gone over in this course with array access, string interpolation, and loops now. And I hope it's all starting to come together. So you guys might be like, okay, well, why would I use this and not the other? The other one seems so much easier to do, right? And I don't have to think about the 0, the up to, but not including and all that stuff. Well, here's the use case for this situation. So imagine we wanted to modify this prices array, right? So here we are printing out the updated coupon price, but our prices array stays the same, right? So we're not really modifying anything. So imagine we wanted to perform some sort of operation where after we go through that for loop, it applies the correct number or updates the value of the item that we're looking at in that prices array. So essentially we're applying a coupon and we want the prices array, the new prices array, to have all of the updated prices. Well, here's how we do that. We can go here and say now prices I minus equals coupon price. And then I want you guys to go down here after the loop runs and print prices. And here we can print prices as well. So we're printing prices in 2 places. Let's just go ahead and run this. Okay, so we notice that the price with the coupon is updated in this statement, but prices stays exactly the same. Here, we are just printing out our prices, but now when we print out the new array, look at what happens. It has all of the updated values with based on the coupon price that we have, which is $10. And the reason we're able to do that is because we have access to the index here in our loop, whereas here we don't, right? So here, yeah, we're able to see what the updated price is, but we're not actually updating this array because we never actually say prices I or prices at 0 equals this new updated price, right? And that's because here we don't have access to the index, so we can't access the items that we need to in the prices array like we can here. So if you're ever running a loop and you just want to do stuff like this and maybe want to just look at the updated price and maybe display that to a user or something, you can do this. But if you ever want to update the original data structure that you're looping through, this is what you're going to have to do there, right? And there's a couple different ways of doing this. This is just one of them. But I hope you guys understand that concept where here we have access to the index of what we're looping through in our array so that we can ultimately utilize that index to modify the original array. Now, I know that might be confusing. I am throwing a lot of information here at you guys. We are going to get a lot more practice with this stuff as the course goes on and as we start doing some practice problems with some algorithms and stuff like that. But I just want to give you guys some exposure to this so that when we see it in the future, you're not totally blindsided. So that's going to wrap it up for this video, guys. In the next one, we're going to go over one more type of loop, which is known as a while loop, and we're going to cover the differences between that and for loops and do some examples with that as well. So get excited for that, guys. We will see you there. Peace. What's going on, guys? Welcome back. Hope you're doing well. This is going to be part 2 of our loops module, where we're going to be talking about something called while loops. So they're very similar to for loops in that they repeat tasks for us, but while loops are conditional. So what does that mean? So a while loop is condition-based, meaning it continues as long as a condition is met. So here's a diagram we're going to go over in a second. The next point is, in order for our loop to stop, the condition has to fail. So if you guys remember from our for loops module, the previous one, for loops have a specified range that they run over, whether we define that range using numbers or we iterate over a data structure, right? It has a clear start and stop point. While loops are going to continue running as long as some condition is true. So let's say, we have some Boolean variable, like while it's daytime. Continue running this loop until it's no longer daytime, and then the loop will stop, something like that, right? So let's take a look at this diagram for a breakdown. So it's going to say, hey, is this condition true? If the answer is yes, it's going to continue the loop, and then it's going to go through the code inside of the blocks, and then it's going to ask that question again. Is this condition still true? And this will continue until the condition is no longer true, and we're going to exit the loop. So we're going to be using things like Booleans, comparison operators, and logical statements to determine whether or not this loop will continue to run. And only until the condition that we specify becomes false will the loop stop. So if that's a little confusing, don't worry. We're about to hop into the code right now and do some examples. So let's go ahead and get Xcode opened up. With Xcode opened up, guys, I'm going to go ahead and paste some notes in here and also create a new section for your while loops. So this is just what we went over in the presentation, right? It's different from a for loop in that it's conditional, and while some condition is met, the loop will continue. It will stop when the condition is no longer valid. So let's go ahead and just dive right into an example. Let's imagine we want to write a program to help us launch a rocket, and we want it to count down from 10, and when it hits 0, then we want it to launch. So we're going to use a while loop to do that. So let's go ahead and create this variable called countdown and set it equal to 10. And now we're actually going to write our while loop. So we're going to say while countdown is greater than 0. Now, whatever is inside of these blocks will execute. That's what's going to repeat in our loop. But I want us to break this down a little bit. So we type out the word while, and that indicates to our compiler that, hey, you're making a while loop. Then what has to follow that is a condition. So this is like, using our comparison operator stuff that we talked about back in our operators section. So if you guys remember, we have these comparison operators, and these will evaluate to either true or false, right? So if I go back, countdown greater than 0 will either give me back a value of true or false, right? Right now, countdown is 10, so countdown is greater than 0, and the loop will continue to run. Then what I want us to do is every time the loop runs, we want to subtract 1 from that countdown guy. So we want it to go 10, 9, 8, 7, 6. And then ultimately, once it hits 0, then this condition will no longer be true and the loop will stop running. So let's go ahead and print out our countdown guy. Countdown is countdown. And then we're going to say if countdown equals 0, and I think we actually want to change this to greater than or equal to 0. So let's do that up there, and then we're going to say if the countdown is 0, print launch the rocket. And what we're going to do now at the end of the loop is say countdown minus equals 1. So we're going to use one of those compound assignment operators, and we're going to say, hey, every time the loop gets to the end of this guy, we want to subtract 1 from the current value of it. So let's go ahead and run this and just see what we get back, and then we can dive through this example a little more. So if you guys look, we see countdown is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and then it says launch the rocket, and then the loop stops, right? So let's just break this down really quickly one more time. So here's our condition, and at the start of the loop, we're printing, hey, this is the value of your countdown. If it's ever equal to 0, it's going to launch the rocket. So this won't print until the last iteration of the loop. And at the end of it all, we say, hey, whatever countdown is, subtract 1 from it. So on the first iteration, it's 10. And, we get back, countdown is 10. And then on the next iteration, because we subtracted 1 from that, it's going to equal 9. And then the updated value of countdown is obviously 9, and then it's going to subtract 1 from that and go to 8, then 7, all the way down to 0. And then once it hits 0, this if statement's going to hit, and it's going to say launch the rocket. But after that, countdown is going to subtract from 0 and equal -1. And then when it goes to evaluate that condition, it's going to say -1 is not greater than or equal to 0. Ultimately, that evaluates to false, and the loop will stop running. So that's just a quick example of a while loop, guys. Something that you need to be really careful with is with while loops, you can end up running a loop infinitely, right? Like imagine we never modified this countdown variable, then the loop would run forever, right? Because countdown will always be greater than and equal to 0. So we have to make sure in our while loops that at some point in the loop, the condition that we are basing the loop on evaluates to false. If that doesn't happen, we will get an infinite loop, and that will crash your program. The loop will just run forever and ever and ever until your program crashes and dies, and nobody wants that. So that's something you have to be careful with while loops. Between the two things, when do you want to use one versus the other? It's pretty situational. Typically, I use for loops most of the time, to be honest, but while loops do have a time and place. And it really just depends on the program that you're writing, right? Like if you want to base a loop off a condition, use a while loop. If you want to base a loop on running a set number of times, use a for loop. That's the main difference here. For loops run a set or preset number of times, whether it's iterating over a data structure or we define a specific range of values, 0 to 10, or loop through this shopping cart array. A for loop will always only ever run a specific number of times. A while loop, however, is conditional, so it will continue to run as long as a condition is true and will only stop once a condition evaluates to false. So that's the big difference between the two. As we go on through the course and, start doing some more practice problems with all of this stuff and get into app development, we'll see when you want to use one versus the other. But like I said, for loops are a lot more common. So that's going to wrap it up for our loops module, guys. You guys are killing it so far, and you are really starting to develop the fundamental skills of what it takes to be a programmer. Now, we're going to be able to start applying this stuff once we get into our app development fundamentals course. And there's just a couple more concepts that we got to cover before we do that so that we can really hit the ground running once we start building real life mobile apps. So we're almost through the fundamental stuff, guys. Let's keep going, stick with it, and we'll see you in the next module. What's going on, guys? Welcome back. Hope you are doing well. As always, in this module, we're going to be talking about something called functions, an essential part of any computer program, whether it's an algorithm or an app or a website, doesn't matter. Functions are used everywhere all the time. So we're going to start this module off by getting into a definition of what functions are. We're going to take a look at some real life examples to help illustrate the concept here, and then we're going to get straight into the code. So really quickly, let's just take a look at this definition. A function is a self-contained block of code that performs a specific task. So you can think of it like a little mini program within your larger program, okay? And it's reusable, and it makes our code easier to maintain, read, and write. So we're going to get into some examples of how that works once we jump into the code. Next up, I want us to talk about some real-life examples of what functions might look like. So example 1. Let's think of a recipe. So think of a function as a recipe. Just like a recipe tells you how to prepare a specific dish, a function provides a set of instructions to perform a particular task. The recipe can be reused to make the dish multiple times, the same way the function can be called repeatedly to perform that task. Another example would be like a mathematical function. So in mathematics, a function takes in an input and produces some output, right? Based on a set of rules. Similarly, a programming function takes in some input values and performs some operations on them and returns an output. So for example, the mathematical function f of x equals 2x will just double any number x that you provide it with. So if you give the number x is 3 to the function, it will return 6, right? If you give it 4, it will return 8. Whatever input you give it, it is just doubling that number. It is performing some operation on the input value that you give it and spitting a value back out with the result of what you want it to do. So that's just 2 real-life examples of what functions might look like. Now that we've gone through that, guys, let's go ahead and hop into the code and start writing some functions of our own to get a better understanding of this concept here. So with Xcode opened up, guys, let's go ahead and create a new playground for our functions. So same as always, just go ahead and create a new file, search for blank playground, and we're going to call this guy functions. So spelled that wrong. Okay, so let's just go ahead and let me start off by copy and pasting our notes in here. You guys should do the same. So this is module 8 functions. They are self-contained chunks of code that perform a specific task, and we are going to have our declaration of a function here. So let's go over how to write a function really quick. So we're going to start out with creating or writing the word func, and that indicates to our compiler that we are about to create a function. So next up, we name the function. So let's write a function that just says hello to somebody. So we're going to call it greet. And then what you're going to do is put 2 parentheses there and open up some curly brackets. So whatever happens inside of these curly brackets or this block is what the function is going to do. So these are the instructions that we're going to give it. And then when we execute the function, it's going to perform that task. So let's just go ahead and say print hello world. Okay, so this is a super simple function. It's called greet, and it's just going to print hello world. And we've written out the function now, so we know what the function is going to do, but in order for it to actually execute, we have to do something known as call the function. So back to that recipe example, right? The recipe contains a list of instructions that will help us make a dish. But in order for us to actually make that dish, we have to execute those instructions, right? So this is what that looks like in a computer program. We just go somewhere below that function definition and say greet. And you'll notice it comes up in your autocomplete window. You can just hit enter. And if we run our code, guys, this is simply going to print hello world. So some of you might be like, well, hey man, why didn't you just say print hello world, like outside of that, right? And the reason for that is because what if I wanted to, execute this multiple times and print hello world like 50 times, right? Then if I want to do that, I can just access this greet function and it will do that every time for me. So I could say greet, 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 and I don't have to type this line out every single time. And this is a super basic example, right? Functions can get really complicated, like in a trading algorithm or something like that, where there's a lot of logic happening and a lot of different instructions being performed, and you don't want to have to write that out every time you want to perform that task, right? So functions give us a way of making things reusable inside of our code. So if I print this, it's obviously going to print hello world 5 times, right? And, another thing you could do is wrap that inside of a loop if you wanted to, but that's just a super basic example of a function. So here we call the function, and let me just add that in there. And I want us to get another example here, guys, where we supply the function with an input parameter. So let's make another mark, input param. And let's go back to that example of like that mathematical function we talked about where it was like f of x equals 2x, right? That's just a function that's going to double a number that we give it, where x is some number that we supply to our function. So here's what that's going to look like. We're going to say func double value, and we're going to pass in an input parameter here, and it's going to be an integer. And then we can just say print x times 2. And let's go ahead and take a look at what it looks like to call or execute this function. So we are going to now say double value, and you guys are going to notice that it asks us for an integer now. So whatever integer we supply it with, let's say we give it 5, and now we run our code, you guys might be able to guess that this is going to give us back 10. So why is that? So we specified an input parameter here, different than this function where there are no input parameters, right? It's just a blank set of parentheses. You place the input parameters inside of these parentheses here. This is what we're going to call the input parameter. Then we put a colon after it, and we have to specify the type of data that it's going to be, so that when we call that function, it knows what it's allowed to accept. In this case, we're giving it 5. If I try to give it like hello, right, and tried to run that, I'm going to get an error. And it says cannot convert value of type string to expected argument type int. So we have to specify the name of the parameter that we want and the data type that it's going to be. So in this case, we said 5. So this is important to understand, guys. Whatever we pass in is treated as this variable x here. So in this case, it's 5, and it multiplies that times 2. So x is just our parameter name. It's unknown until we actually call the function and supply it with a value. So, I could then go here and say double value 7, double value 12, and run my code. And every time I execute this function, it's just going to double that value for me. So we can see how this is going to start to help us out a lot when we're writing computer programs, right? We can write these reusable blocks of code that help us perform tasks. And right now, these are really simple tasks. But like I said before, these tasks can become very complicated. And functions are going to help keep our code super clean, reusable, easy to write, easy to read, all of that stuff, easy to maintain. Good programmers write a lot of functions, okay? Next up, guys, I want us to talk about what it looks like for a function to actually return a value or spit something back out. So right now, it's important to note that these functions are doing things, but they're not actually returning anything or giving us back a value, right? So with that mathematical function, like right now, we're just printing out x times 2. But functions can actually give us back a value. So let's take a look at what that looks like. So mark return a value. We're going to say func, and we could say like, triple value x int, and we're going to type an arrow like that. So it's just a dash and a caret, and we want this to give us back an integer. So here we can say return x times 3. And now let's go ahead and call our function and see what happens. So we can say triple value 9 and run that. So you guys notice it doesn't print anything to our console, but it does give us a return value of 27. So this function is actually giving us back a value. So that means we could like store it in a constant. So we could say let result equal triple value of 9, and then we could print out our result like that. And we get back 27. So there are a lot of situations in which you want functions to spit something back out for you, right? And then there are some times where you don't need it to do anything. You just need it to execute some sort of task. And in the example of the recipe, like obviously we want the function to that kind of function to give us back a meal, right? But imagine you wrote a function for an exercise routine. That's just performing tasks. It's not actually giving you back anything, right? It's just doing exercise. Whereas the recipe is performing a set of tasks and giving you a meal out of it, right? So there is a difference between functions that return things and don't. The things that don't are just doing stuff. The things that return stuff, they also, perform a set of tasks or perform a set of instructions, but they ultimately give us back a value. That's very important to understand. So I want to just break down what's happening here a little bit more before we move on to another example. So when we want a function to return a value, we use this arrow notation and specify the type of value that we want it to return. And then we use this return keyword here to ultimately accomplish that task. So if we don't have that, and like let's imagine we just said print x times 3, we're going to get an error. Okay, it says cannot convert return of expression type empty, which is what those parentheses mean, to type int. So basically it's saying that, hey, you told me this function needs to return something and you're not doing that anywhere. So we can't use that print command. We could say return x times 3. And you guys could also print x times 3 in that function if you wanted to. Functions can be as many lines as you want them to be, but ultimately we do have to return something here. So let's go ahead and write another example of a function that returns a value, guys. So let's write a function to see if we can add two numbers together. So I'm going to write a func, and we'll call it add numbers. And imagine you want this function to add any two numbers that you give it. Well, we're going to need two input parameters, and then we're just going to add them together and return that value. So let's say we want x, which is an integer, and y, which is also an integer. And we want this to return a value, so it's going to give us back an integer as well. And we could say let sum equal x plus y and return our sum. And now we're going to have a function to help us add any two numbers together. So we could just say add numbers to, and you guys can just tab over once you enter the first input parameter, and it'll go to that spot, and it's asking us for another integer, and say 5. And let's run that. And you guys will notice it won't print anything, but it is just going to give us back 7. Okay, so that's pretty cool. Let's see if we can write another function to do something like help us calculate someone's age, right? So let's say func get age, and let's think about what we need to figure out someone's age. Okay, we need to know their birth year, and then we can look at the current year and subtract their birth year from that, and that'll give us back their age. We did a similar example to this earlier in the course. We're just using a function to do this now to make this reusable. So we need to pass in our birth year, which is an integer, and it's going to give us back an integer as well. So let's go ahead and say let current year equal 2023. Let age equal birth year minus current year, or sorry, it's going to be current year minus birth year. And then we can return age. So now that we have a function that will get us back the user's age, let's go ahead and see if we can write another function that's just going to print it out to the user. So we'll write a function that's called display age, and it's not going to return anything. We just want to execute a print statement here. So we want to get the user's age and then display that back to them. So we'll say let age, and this is the concept I want to illustrate here, guys, is we can call functions within other functions. So I can use this get age guy that I just created as sort of like a helper function here, right? And then it's going to store that value that it gives me back in this age property. And now I'll be able to use some string interpolation to display that age back to the user. So I could say print you are age years old. And if I run this, we haven't called this yet, so it's not going to do anything. So let's make sure we do that. Let's say display age, and that will print out you are 32 years old. So now let's make it so that we could make this function get us back the age of any user with any birth year, right? Right now it's only displaying the age of someone who's going to be born in 1991. Let's imagine we want to set it up like this to where we can pass in the birth year of the person at any time and then have it display their age back to us. So what we can do is actually just have an input parameter for birth year here as well, which is an int, and then we can replace this 1991 guy with our birth year. And now you're going to notice this gives us an error. We have to pass in our birth year here, and I could say like 2005 display age 1999, stuff like that, right? Now let's run this and let's see what happens. And let's do a quick breakdown of how that works. So you see we are 18 and we are 24 down here. So this is a really cool concept here, guys, where, like I said, we're using functions within functions, right? We're using this get age guy as like a helper function to help us figure out the user's age and then ultimately display it back to them. So how did we do that? Well, we wrote this function. I think this is pretty straightforward by now. We pass in a birth year, we compute their age, and we return it. Now to display the age, well, if we want to make this dynamic, right? Instead of just passing, like hard coding like 1991 or 2005, we want to make it so that anytime we call this function, we can pass in a birth year and it'll figure out the person's age for us, right? So we have an input parameter here as well, and we pass that along to our function get age. So whatever I do here, so say 2005, it's going to use that 2005 value in this function, right? So the birth year is this guy that I'm passing in, and then it's going to go up and this function is going to call, and it's going to be like, okay, I know birth year is 2005. We sort of passed it down this chain, and it's going to compute the age and give it back to us. So, you know, you can name these input parameters whatever you want. Like, let me name this like year of birth or something to make this more a little more clear. And let's copy year of birth right there in those two spots as well. So I think this will make this a little bit more clear. It might be confusing when you just see birth here over and over again, right, guys? So in this function display age, we have an input parameter. It's the same exact type of setup. We just called it something different, right? We're saying year of birth. So in this case, we passed in 2005. So year of birth is 2005. And then we say let age equal get age. And this is asking us for a birth year up here. And we're passing in that guy, year of birth, which in this case is 2005. So that's going to go all the way down the chain to this get age guy. And it's going to say current year, which is 2023 minus birth year, which in this case is 2005. And then it's going to return our age for us. So that's super cool right there. It's a little bit more complex of an example to show you how powerful functions can be and how they can help us do things in a much more efficient way because we can reuse that stuff, right? Like I don't want to have to type this code over and over again to perform the same task. I can use functions to make my code reusable and execute that stuff whenever I want and accomplish all of this stuff in one simple line of code when I call the function. So that's why functions are super helpful and super useful for us, guys. We're going to get a lot more practice once we do some more problems and build some applications. But this is going to wrap it up for our functions module for now. We're going to be moving on to the next section where we're going to be talking about something called optionals. So once again, you guys are killing it. Keep sticking with the program here. We're almost done with the fundamentals, and then we're going to get into the app development fundamentals, which is going to be where all of this stuff is going to come to life, and you're really going to be happy that you spent the time working on the fundamentals. So the app development stuff is going to be super simple. Let's go ahead and get started with our next module, guys. What's going on, guys? Welcome back. Hope you're doing well. In this module, we're going to be talking about optionals. So we're going to go over a definition, go through some real life examples of what optionals look like, and then we're going to hop into the code and start working with them. So let's take a look at our definition here. So an optional value allows us to code more safely when working with properties that may or may not have a value. So what exactly does that mean? Well, let's take a look at this example here. So I'm sure at some point you guys have all filled out some sort of form that looks like this, where one of these fields is going to be optional. We see down here that this phone number field is optional. That means you can either enter a value in there or you can leave it completely blank. So let's talk about what that's going to look like programmatically. So all of these fields here, first name, last name, email, we are, just stating that they're going to be strings. So whatever the user were to type into this field would get stored in this first name property, and then I could use it however I want to. And when I get all the way down to phone number, we see that this is different because it has a question mark next to it. So in Swift, this is how we denote that a property is going to be optional. So it has one of two potential states. It might have a value, and that value could be a string, or it might not have a value at all. So the value would be nothing. And in programming, we refer to that as nil. So next up, what we're going to do is hop into the code, guys, and start working with optionals, see the type of situations where we're going to want to use them, and see why they're really beneficial and helpful for us when we're writing apps and computer programs. So let's go ahead and jump into Xcode now. All right, guys, so with Xcode opened up, let's go ahead and create another playground. So going to go up there and we're going to create a new file. As always, it's just going to be a blank playground, and we are going to call this optionals. Okay, so let's just delete this stuff really quickly, and let me paste my notes in for this module. And once again, you guys should pause the video and type that stuff out for your future reference. But what I want us to do is start off with an example of when you might use an optional property in a real life application. So I've built this Instagram clone, and this is something we're going to be building in the app development courses. And what I want us to talk about is this user bio property. So if you guys have ever used Instagram before, you probably know that entering a bio is optional. Entering a profile image is also optional, right? So the concept here is that these things may or may not have a value. A user might have a bio, they might not. They might have a profile picture, they might not, right? So if they do, it's going to show up there. And if they don't, if we go to Spider-Man's profile, we'll see that he doesn't have a profile picture and he doesn't have a bio. So he chose not to fill those fields out, so they don't display in the application. So this is the concept of when you're going to want to use optional properties. So we're going to go ahead and mimic this example in our code with an example right now. So let's go ahead and hop into Xcode here, and we're going to create a couple properties. We're going to create one for like username, and we can call it Batman. And then we're going to create another property called bio. So we're going to say var bio. You're going to put a colon there. We're going to state that it needs to be a string, and then you're going to put a question mark after it. And as we talked about in the presentation, this means that this is going to be an optional property. So as we see in our notes, it could have one of two potential states. It can either contain a value or be nil or nothing, right? So if the user ever chooses to enter a bio, then it'll have a value. But if not, nothing will be there. So this is how we sort of safely deal with properties that may or may not have a value. Okay, so let's go ahead and write a function here that's called getUserInfo. And it's just going to print out our user's information to us. So let's print out our username. And then let's see what happens if we try to print out the bio. And let's go down here and call our function getUserInfo and just hit play to run that. Okay, so username is Batman, and we see that bio is nil, guys. And then we get this error, or sorry, it's just a warning, but don't really worry about that for now. What I want us to do now is go ahead and actually supply this bio property with a value now. So if you guys remember, in order to do that, to mutate a variable, we just access it like this, and then we use our assignment operator, our equal sign, and we give it a value. So now I can say Dark Knight or something like that, right? And then let's call our getUserInfo function again. So this sort of goes back to our functions module, right, guys, where we don't want to have to retype these 2 lines of code every time we want to do this. So we're just wrapping it inside of a function, and then we can reuse that function anywhere we want. So what's going to happen here is when I run this, now my bio is going to have a value. So we should get something different back from our function call. And that's exactly what we see, right? The second time we call this function, because we gave bio a value on line 21 and then call the function again, it's going to print out our bio. But you guys see that it is sort of wrapped with this optional wrapper right here. So we see optional, and then it's sort of wrapped inside of these parentheses. So I want to just give you guys a quick analogy that's going to really explain this concept here. So let's imagine that this bio variable is like a container, right? That's what variables essentially are, as we talked about in the first module. They're containers, or like boxes that store values or information, right? So let's think of this as a literal box or container. And when we open that box, it may or may not have something inside of it, right? It could be nothing, or it could be a string. And if we want to use that property and actually work with it, we have to extract it from that box or pull it out of there before we can use it, right? So the first time we call the function, there's nothing in the box. The second time we call the function, we open up the box and say, hey, there's something in there, but we need to pull it out of that box before we can use it. And this concept is known as unwrapping something in Swift. So we want to unwrap this optional so that we can use it safely. And I'll go over what I mean by safely in a little bit. I just want to go over how to start working with these optionals and unwrapping them, guys. So in our getUserInfo function, I'm going to add some comments here. This is unwrapping our optional and extracting the value. So this is one way of doing it. We're going to go over multiple ways of doing it. So we're going to say if let unwrapped bio equals bio, print user bio unwrapped is, and then do your string interpolation with the unwrapped bio. So I'll explain what this means in just a second. Let's just go ahead and run our code again. Okay, so the first time, let me actually just add a divider here so we can distinguish between the function calls. So go ahead and just add like a divider at the end of your function. So every time it calls, it'll, sort of split up the calls in our console just like that. Awesome. So the first time we call it, we get these 2 lines of code, but we notice that this if let statement never executes, right? We don't ever hit line 23 in the first time. But the second time we get username is Batman, bio is optional, Dark Knight. But then we notice the third line of code is really interesting, right? We see user bio unwrapped is Dark Knight. And this is ultimately how we would want to use this stuff. We don't want this nasty optional property wrapper there. We want our property to be unwrapped so that we can see it as a plain string like that. So let's break this if let statement down really quickly, because this is something that a lot of beginner programmers get confused with. I was really confused with this concept when I was teaching myself how to code. So I want to break it down for you guys. So we're saying like, hey, if the bio property has a value, then we want to store it in this property right here. So we say, basically we're saying if bio exists, store that value in this unwrapped bio property. And that unwrapped bio guy will not have this optional wrapper here, because we are basically safely checking to see if bio has a value. And if it does, we store that string that we want to use, that we want to pull out of the box, and we're storing it in this property here. So we're basically saying if we let unwrapped bio equal to bio, then we can safely use that property. So what exactly do I mean by safely here? What's the logic behind that? Well, you can imagine that things might get messy if you try to use this value and it's not there, right? So in your program or your app or whatever, if you're saying like, hey, use this property and let's assume it's there, but for some reason it's not, it could cause your program to crash. So essentially what this if let statement does is it gives us a safer way of using that optional property, right? Because if and only if this has a value, will this if block execute. So we're only going to go down this path if bio has a value. And we can see that situation in the first function call where bio doesn't have a value at that point. Bio only has a value as of line 31. Everything else before bio is nil, right? So we don't ever go down this path because bio is empty. It's nil at that point. And then we do end up going down that path, and then we can safely use that property via this unwrap method with an if let statement once bio does have a value. So this gives you, like I said, just a way of being able to safely use these optional properties. And we're going to go over a couple other ways of using or unwrapping optionals. The next one being the unsafe way of doing things. So this is where you might run into trouble with your program. And this is typically something you should never do, but it is an option for certain scenarios. And I'm going to show you how this could cause your program to crash. So Swift has something called a force unwrap. So basically, guys, if you go up here and just put an exclamation point after your bio property, this is going to tell your compiler to, hey, unwrap this thing no matter what. I'm not going to be safe here. I just need you to use this thing. Whether it has a value or not, I don't care. Force unwrap it, right? And like I said, there is a time and place for this, but typically you want to avoid this at all costs, because if we run our code here, the first time we call this function, it's going to try to force unwrap that bio property, and there's going to be nothing there. So this will cause your program to crash. So we're going to run that, and we notice here that in the first function call, we get some really convoluted error here. But if you look at the console, we see fatal error, unexpectedly found nil, while unwrapping an optional value. So this is a big no-no, okay? So I'm just going to add a comment here. Can use exclamation point to force unwrap, but this will cause crash. Okay, so that's, like I said, typically something you never want to do. But let's go over a situation in which it would be okay to do that, but we'll see why the if let way is better. So I could say if bio is not equal to nil, then we could say print bio unwrapped is bio. And use your exclamation point there to force unwrap it. And guys, if we run this again, we'll notice that we don't get a crash, okay? And that's because basically we're doing almost the same thing this if let statement is doing it. We're just doing it slightly different, right? So we're basically checking, hey, if bio is not equal to nil, then we can force unwrap it, because in this case, we know that bio will have a value because it's not equal to nil, right? So we can see here that this guy hits on line 27 in our second function call, bio unwrapped is dark night, and we're using that force unwrap, but the only reason we can use it safely there is because we initially checked to see if bio was equal to nil or not. So that's basically what the if let statement is doing. It's just doing it in a cleaner way, right? we're saying like, hey, if bio has a value, store it in this property. Or another way of saying that is if we let unwrapped bio equal bio, then we can safely use it inside of that if block. It's essentially, like I said, doing the same thing as this, just in a cleaner way, so we don't have to use this nasty force unwrapping and all of that stuff. And another note, guys, is you can name that property there whatever you want. I just named it unwrapped bio to sort of make things clear to you and which property is which. This is referring to our bio guy. And a quick trick in Xcode that I don't think I've let you guys know about up until this point is if you just click on a property name, it will highlight everywhere that property is being used. So like if I just go hover over bio, I can see that this is referring to my bio up here, and that's being used right there and right there and right there. And if you guys hover over this if let property, right, you can see that I'm using that inside of this guy right here, inside of this if block. So it is important to note that you can name this property whatever you want. I could call it X, right? I could even call it, and this does get a little confusing for some people, I could even call it bio. And you guys might be like, hey, I thought you said you can't duplicate variable names, but because this is within an if let statement, it's okay. And I know that might be confusing for now, so don't really worry about that. But like I said, we'll get tons more practice with this stuff as we go. Next up, guys, I just want to work with another example to show you some other ways of how we can unwrap optionals. So let's go ahead and make another section here, guys. We're going to make a mark, and we're going to call this one default values. So another way of unwrapping an optional is supplying it with a default value if the optional property isn't there or if it's nil. So what exactly is that going to look like? Well, we're going to do an example here where imagine we're filling out this form and we have a first name and a last name property, and we are going to add in like a middle name guy. And that's almost always optional when you fill out these types of forms. And then we're going to try to build a full name out of all of that stuff. So we're going to try to combine all of those names from those fields and see if we can produce a full name for the user. So let's go ahead and go back to our code here, and we're going to create a variable for our first name, John, var middle name, and this is going to be an optional string because it may or may not be there. The user has the option of whether or not they want to enter their middle name in this form. And then we're going to make a variable for our last name, and we can make that Smith. And then we're going to make a function to try to get the full name. And we're just going to return a string, and we're going to say return, and we have to do some string interpolation here, right, to sort of inject these values into our string. This should be a familiar concept to you. And we're going to say first name space middle name space last name. Okay, so let's go ahead and call this function and see what happens. Run your code. And we see that we get back John Nil Smith. And that's really ugly, and we would never want that to show up in a real life app or program, but it is working as expected. So because middle name is optional and it doesn't have a value, the compiler processes that as nil. And we would never want to say, hi, John Nil Smith, right? So what we have to do is unwrap this property. And we're going to do or use a default value to accomplish that. So I'm going to go ahead and create another property called middle unwrapped. And we are going to say it's equal to middle name. And the way you supply something with the default value is to use 2 question marks and then say like default value for now. This is obviously just for testing purposes to show you guys what this is going to do. And then let's replace middle name with middle unwrapped. And let's run our code again. And you see that it's now John default value Smith, right? And that's obviously not what we want. This is just to show you how the default value stuff works. So basically this is saying that if middle name doesn't have a value, I'm always just going to default to this value that you're giving me. And this is a string, so it's all working fine. Like we can't go here and give it a default value of 0, right? Because it's a string and then we're trying to give it a default value of an integer. So what we actually want to do here, guys, is just make this a blank string, okay? So it's literally not going to append anything to this return statement. It's just going to be a blank set of quotes. If you made it a space on accident, it would put an extra space in there, which looks weird. So we're just going to make that a blank string. So it literally just does nothing if it's not there, right? Which is what we want. Hi, John Smith. But if we do give it a middle name, John Alex Smith, and then call this function again, so now middle name has a value, it's going to be John Alex Smith, and it's not going to have that nasty optional wrapper inside there. It's just going to say Alex. And the reason it's safely unwrapped is because we have supplied it with the default value. So our compiler knows that if it's ever not there, if it's ever equal to nil, it always has something to default to. So that's how you unwrap stuff with default values. So you could also use an if-let statement to do this, and you guys might be like, okay, well, when do I use one versus the other? And it's really personal preference. So if-lets are acceptable here, default values are acceptable here. It really just boils down to what you want to do and what you're more comfortable with. There's a lot of different options we have, and that can make things a little overwhelming, but it's also good to have those options so that if one makes more sense to you than the other, you can go ahead and use that. We are going to go over one more example with how to unwrap optional values, and it's going to be using something called a guard statement. So let's go ahead and make another section for that and do one more example before we finish up this module. So we're going to say mark guard statements. So let's go back to this form, guys. Let's imagine that, we have this form in an application, and once the user fills it out, we want to send some sort of confirmation text message to them, right? So the only problem is we're not forcing them to input this phone number. It's an optional field. So let's go ahead and see how we would write a program or function to safely do this and handle the case for when the phone number isn't there and handle it for when it is. And we're going to use a guard statement to do that. So basically, let's create two properties. We're going to create an email property and set test@gmail.com. and then a phone number property. So we can see here that the email property is required. So we're just giving that a value, right? But the phone number property is optional. So we're going to write a function to say func send confirmation. And it's going to either send it to the email or the phone number. Okay, so basically the logic behind this is we're going to say if the phone number is there, send a confirmation text message. If it's not, send a confirmation email, right? This is pretty common for what you would see in this situation. So we're going to use a guard statement to do that. We're going to say guard let number equal phone number, else return, okay? So I know this might be a little confusing. We're going to go over it in just a second. Then we're going to say print send confirmation to number. Or we could say send text confirmation or something, right? And let's go ahead and say send confirmation. And if we run our code, absolutely nothing is going to happen. So why is that? So I want to talk a little bit about this guard statement that we see here, what it's doing, what it means, and how it's different than an if-let statement. So basically, guys, when we used our if-let, this is basically going to say, hey, go down this path if this thing has a value, and then you can safely use that unwrapped value. It's the idea of going down a path if a certain condition is met, right? Well, a guard statement is much less like a path, and it's much more like a wall. So it's basically going to say, hey, if the number's not there, we're going to stop right here. You have hit a wall. This function will stop its execution right here on line 62. So we could say print, check this out. We could say print did call function or something. Run that. And we'll see here that we called the function, right? So that print statement is executing. But it hits this line on 63, and because phone number is nil in this case, it returns. It stops right there. That's what the return means in this case. So it's basically saying, make sure the phone number's there, else, or if not, stop and return. And it's important to note that anytime we say return in a function, that is equivalent to stopping the function right there in its tracks, or like hitting a wall, so to speak. And we're used to seeing return and seeing like a return value. And we'll come back to that in a little bit. But because this function isn't returning anything, we can just say return here. It doesn't return anything, and it just stops the function right there. So this really showcases the difference between if-let and guard-lets. Guards are like a wall that the program hits if the condition is not met. In this case, phone number has to have a value, and if it does, it gets stored in this number property. Then we can continue on with the rest of our function and use that property safely because we know it's there. And if it's not, it stops right here. Whereas an if-let statement goes down a particular path, right? So everything else has to go, like to use this property, you have to be within this path or this block of code in order to use that. Whereas with the guard guy, we can just continue on the function regularly because we're using a wall instead of a path. That's how I sort of like to think about it. So we can also put code in this else block, guys. So if you remember the original requirements of what we were talking about, we say, hey, if the phone number's there, then I want to send a text confirmation, but if it's not, I want to send an email confirmation. So this is the case for when it's not there. So just hit delete that return statement for now and hit enter here. And then we could say print send email confirmation to the email address. And we always have to say return. That's the nature of a guard statement. The else block that we see here has to return because that's like how the guard statement is going to work. Okay. So now we can run our code again, and we're going to get this print statement here. This means the phone number did not have a value, so we entered into this else block and the function stopped right there. You guys can see that we never print out this send text confirmation to email. Once again, that is because it stopped the execution at line when it did this guard statement check. And we're just going to go ahead and send the email confirmation. But I'm sure you guys could imagine that if we set phone number and give it a value, 555, 555, 5555, and then call send confirmation again and run our code, then it's not going to say, hey, send an email confirmation. It's going to say send a text confirmation to 555, blah, 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 blah. Another way of doing this, guys, would be to say if let phone number equals phone number and else send email. So we could just say send email, send text, right? So this is just another way of accomplishing the same thing, same, but different. So you guys might naturally now be asking, okay, well, when do I use one versus the other? So before we end this module, I'm just going to talk a little bit about some different situations in which you might want to use guard statements versus if statements versus default values. And we will also get a lot more practice with this once we start building applications and, have different situations in which we can apply these concepts. So a big reason I like to use guard statements over if-let statements some of the time is that if-let statements can, one, get really messy. So you guys might imagine that if you had like 10 properties you needed to unwrap and check, and if you had multiple if-let statements, your code would start to look like this: if-let, if-let, if-let. Right? And then you start to get this really nasty like pyramid of brackets, and that makes your code really hard to read and really hard to understand what's going on because of all those like different pathways that you're going down and all of those nasty brackets that you have. So guard statements allow you to avoid that by, keeping your code in line, so to speak, where you don't have to open up a set of brackets and go down a path. You can just set up walls that your program will hit if those conditions aren't met. But there are certain situations where you would want to use if-let statements as well. Like sometimes you don't want that wall there, right? Sometimes you want to just say, hey, go down this path if necessary. And if you don't have to go down that path, that's fine. But I want you to continue the execution of the program, right? So guard statements will stop you in your tracks if the condition isn't met, whereas you can continue the execution of a program with an if-let statement if you want to. So that's sort of, some different situations that might occur with guard and if-let statements. But it really boils down to personal preference, guys. There's nothing you can't accomplish with one versus the other. It's just a different way of accomplishing the same thing. And it's nice to have those options available to us. And with default values, like in this example, you wouldn't want to give someone a phone number with a default value, right? Like the user has to provide that value. So you might not want to use a default value there. But in this example, it's perfectly acceptable, right? Because we could just make the middle name an empty string. So each thing has its own time and place. And like I said, once we do more examples with this stuff, we'll get much more practice with it and a better understanding of it. But the goal of this video was to showcase optional properties and how they work, guys. And I think we've done a really good job of that here. we can see how optional properties work and what their use cases are. And we have a bunch of different options of unwrapping them in order to use them safely. And this is going to make our life a lot easier when we're working with properties that may or may not have a value. So that's going to wrap it up for this module. In the next one, the final module of this course, before we get on to some really awesome app development stuff, is going to be looking at classes. And then that's the final module. Then we're going to do a bunch of practice problems just to work our programming muscles before we really get into the fun stuff with app development, guys. So get excited. We'll see you there. Peace. What's going on, guys? Welcome back. Hope you're doing well. In this module, we're going to be talking about something called structs or structures. And we're going to start this off with the definition. We're going to go over some real world examples, and then we are going to hop into the code to do some examples of our own. So let's go ahead and get started with our definition here. So a struct or structure is a template definition of properties and functions that define a programmatic representation of an object or thing in an application. So this could be a user, a video game character, a product, a vehicle, so on and so forth, right? Like, how do we represent these things programmatically in our applications? So let's hop over to the next slide and take a look at what that's going to look like. So let's imagine we have some really simple user object that I'm going to call it, or thing that we want to represent programmatically in our app. So we see this all the time in apps like Instagram, Twitter, Tinder, whatever it may be. Anytime you sign up with an account and have to log in, you are considered a user of that application, and there is data associated with you. Your name, your age, your username, your bio, whatever it may be, right? So this is how we're going to represent that programmatically in our application. So let's imagine we have a really simple user object here. That's what I'm going to refer to these things as, guys. But you can think of it as a thing, right? I have a user in my app. What do I want that to look like? Well, each user is going to have a username, a full name, and an age. And this is how we're going to define that programmatically. We're going to create this struct or structure. We're going to call it a user. And then we are going to define the properties that this user is going to have. So we're going to say you're going to have a username, a full name, and an age. All of the users in my application are going to have these three properties. And when I go to create this user, this is just considered a blueprint of the user object. Then I can create them and supply it with values. So for example, if I want to create Batman as a user, I would say Batman is a user, his username is Batman, his full name is Bruce Wayne, his age is 35. Then let's say I wanted to create the Joker as another user. Well, it's the same thing. I just give each property different values, right? His username would be Joker, his full name could be Heath Ledger, and he could maybe be 32 years old. So let's talk about one more example before we get into the code. So let's take another look at this Instagram clone that I've built here, and let's consider what a post is, right? A post is an object or a thing that we would want to represent programmatically in our application. Now let's think about all of the metadata associated with a post, right? And sort of think about how you would structure that in your code. So a post has what? It has likes associated with it, right? And that's an integer. So you would say let likes be an integer. And then it has a caption, which is going to be a string. It has a username, which is a string. It has an image, which is some other type of data that we'll get into later. It has a username associated with it, like comments associated with it. All of these things are associated with this post object that we're going to call it, right? So you could think about how you would define that using this sort of format here. And then this feed is ultimately just a list or an array of those posts that we can scroll through. So that's sort of the foundations of how you're going to be developing mobile applications, guys. And we're going to hop into the code now to really get some practice with this stuff before we try to apply it when we start building apps. So let's go ahead and hop into Xcode now. All right, guys, so we are going to create yet another playground, and you guys should know how to do this by now. So we're going to create a blank playground, and we're going to call this guy Structs, okay? So let's just go ahead and see if we can recreate that struct we talked about with the user object. So this is what it looked like. Let's just go ahead and type this out and see what we get. So we're going to create a struct, and we are actually going to capitalize this user, guys. So structs always get capitalized. So function names and variable names and stuff, they have that sort of camel casing where, first thing is lowercase and then everything else is uppercase after that. Structs, default naming convention, you capitalize them with the first letter. So we have our struct, which is a user. We are going to say let username be a string, let full name be a string, let age be an integer. So that's pretty straightforward, right? This is a data structure. It's called a user, and it has these three properties. So here's where it gets interesting, guys. Let's see if we can create a user and see what that looks like. So I'm going to say let user1, and then you can just say user, and you guys are going to see some things pop up in your autocomplete window. So we're going to go here, and it's going to ask us to supply it with these values now. So this is how we create a user. So this is a very important distinction to understand. This struct that we have created here is the blueprint for what the user is going to look like in our application programmatically. That's our programmatic representation of a user. But much like when we write out a function, we still have to call it. When we create a data structure, it's just the blueprint for that object. We still have to create it and supply these things with values. So every time I go to create a user, this is what it's going to look like. So this is what's known as creating an instance of my user object. So I'm going to give my username Batman. Bruce Wayne is the full name, and we can say 35 is the age. So go ahead and see if you guys can create another user object. It can be whatever you want. So just go ahead and pause the video and see if you can do that. And when you come back, this is sort of what you should get, guys. We're going to say let user2 equal user, and then we're just going to open up our parentheses and hit enter for the autocomplete. And then we're going to do the Joker. And his name, he can be 36. And then, let's create maybe one more. User3 equals user. And oops, got to get my autocomplete working. Iron Man and Tony Stark. And he's like, let's say, 40. Okay, so we have 3 users. So now let's take a look at how we're going to access information about each individual user. This part's pretty cool. So let's just go ahead and see if we can print out some information about some of our users. So I could say print user1 is, and then we're just going to go ahead and do some string interpolation, and then type out user1 and then say dot. And then you guys are going to notice that we get access to each one of those properties that are associated with the user. And if I, ask for the age, it's going to go and find user1 and give me back that user's age. If I were to do this for user2, it would give me back 36. User3, it would give me back 40. So let's go ahead and see how that works. And we see that user1 is 35. And, let's go ahead and just copy and paste that and maybe say user2 is, and then we could say like user2 dot username, right? So this is really interesting here, guys, and now we can see how we can sort of organize all of this information into a single data structure and then access that information about our user with this dot notation. So it really ends up looking like this, right? So we have a user, and that user has all of these properties, or each individual user has all of those properties, and then we can access those properties about each individual user just like that. Another really awesome thing that we can do with data objects like this is we can put them into an array. So like I could say like var users, and we could make it like a blank array of users, and I could say users.append user1, users.append user2, users.append user3. Okay, so now I have this users array, and you guys might be wondering, okay, well, like what might you do with that? Well, let's take a look at this Instagram application once again. And this list of users here is going to be represented programmatically just like we see here with this array. So this list is essentially just an array of users, and we are looping through that list and displaying each user on our screen here. And we're obviously going to go over how to do that once we start building apps, but this is the foundation for how that works, right? We have these data structures, we place them inside of an array, and then we can ultimately display them in a list. So Now that we've gone through, some of the basics of data structures, I just want to create a couple more examples and show you guys a little bit more functionality about how they're going to work as well. So next up, guys, I want to see if we can create a data structure to represent a vehicle programmatically. So I want you guys to go ahead and just pause the video and see if you can create a vehicle struct and give it some properties about things you might think you would need to represent a vehicle programmatically. Like a user had a username, a full name, and an age. Try to think about what you would want a vehicle to have associated with it, or the information you would want associated with it, and then come back and we'll do it together. Okay, guys, so let's go ahead and say struct vehicle, and this is what you should have got to start. You could call it whatever you want, car, vehicle, doesn't matter. And I'm going to make this pretty simple. Like, I'm just going to give it a make, a model, a year, and maybe horsepower, right? So we can say let make, and that's going to be a string. Let model be a string. Let year be an integer, and let horsepower be an integer as well. Okay, so hopefully you guys' vehicle looks something like this. Like, you definitely want the make, the model, and the year in there. You can obviously make this a little bit more advanced. Like, you could have number of doors. You could have whether it's electric or not. Like, right, you could add maybe let is electric, and that could be a Boolean variable. Like, the basic idea behind this, guys, is I want you to get some practice with how to represent things in your applications programmatically. So think of like a real life object, and then think about how to translate that into code. That's a foundational skill that any good programmer is going to have. How to make real world things be represented in a program. But we're going to stick with this for now, and let's go ahead and just create some instances of our vehicle. So when I say instance, once again, that means I'm just going to go ahead and create a vehicle structure. So I'm going to say like let v1 equal vehicle. And like I said, guys, this is referred to as an instance of this data structure. This is the blueprint for that vehicle. This is an instance of that vehicle. So let me maybe make it a Ferrari. This could be a 488, 2019, horsepower 600. Okay. And then we could just copy and paste that, call this guy like V2, maybe make this a Lamborghini. And then this guy could be like Huracan. Year is 2021, horsepower, maybe let's make it like 650. So I know those numbers aren't accurate. If any gearheads are out there, don't get mad at me. What I want us to do next, guys, is add a function to this vehicle structure that's going to help get us back some information about the car. Okay, so this is going to illustrate the concept of a struct level function. So if you guys remember from our definition, we see that a struct is a template definition of properties and functions that define a programmatic representation of an object. So let's just imagine we want to write a function to help us get back the information of a car, to maybe display it to a user in like a nice sentence or something, right? So let's write a func and make sure it's a part of your vehicle data structure. And then we're going to say like get vehicle info. And we're just going to like write a print statement out. We're going to say like, hey, we want to say like this is a Ferrari 488 that was made in 2019 and it has 600 horsepower. Let's see if we can write that out. So we can say this is a make model. So this is a Ferrari 488 that was made in, and then we're going to pass in the year, and it has horsepower. So now let's take a look at how we're going to use this function, okay? So I'm only able to access this function through instances of my data structure, right? Because this function is contained within this vehicle struct. So I can only access it through something like V1 or V2. So I have to create an instance of my vehicle, and then I can call this function on that. So let's see how that works. I'm going to say v1.getVehicleInfo. You guys see it comes up right there. And let's go ahead and hit run. And we can see that that gives us back exactly what we want, right? This is a Ferrari 488 that was made in 2019 and it has 600 horsepower. So how exactly is that working, right? So we're passing in all of these properties here and it's giving us back all this information that we want. Well, we are calling this function sort of through extension of this vehicle one that we've created. And in this instance, the make is Ferrari, the model's 488, year 2019, horsepower 600. So when the vehicle, this function here, is looking at all of those properties, it's going to say, hey, I want to pass in the make here. And for this instance of that vehicle, it's a Ferrari. When I want to pass in the model, in this case, it's 488. And then it's same, for the year and the horsepower. Now, if I say v2.getVehicleInfo and go ahead and print that out, it's obviously going to give me all of the information about the second vehicle. And the reason behind that is even though we are passing in, these sort of generic properties of make, model, year, and horsepower, in this instance, those things are equal to these values, right? So once again, guys, this illustrates the concept of this just being a blueprint for my vehicle object. All vehicles will have these properties. And when I create the vehicles, I have to supply those properties with the values that they need in order to actually create the thing. So this is the blueprint. These are the instances of where we are creating that vehicle or that object. And it was the same with our user. And that's going to wrap it up for our module on structs, guys. We got some really good practice with how to represent real life things or objects programmatically. In the next module, the final one of the course, we're going to be doing some exercises that combine all of the concepts we have learned thus far in this fundamentals course. It's going to give us a better understanding of how all of this stuff works together. Real big picture stuff. It's so important to make sure that you guys have a solid foundation in programming and problem solving before you move on to developing apps. So once we do that, you'll have everything you need to hit the ground running and start building apps like a pro. I see so many developers fail when they start trying to start building apps too quick because, like I said, that's obviously the fun stuff. You want to see something come to life. You want to build that app idea you've had for forever. You want to start making money right away. But if you skip the fundamentals, it will always come back to haunt you in the end. So let's go ahead and get started with this next module, guys, the final one of the course where we're going to be doing some exercises that really brings all of this stuff together. What's going on, guys? Welcome back. Hope you're doing well. In this module, we're going to be doing a couple exercises, like I said before, to really cement our understanding of everything we've done thus far in the course. So let's go ahead and create a new playground for that. So we're going to go here and once again, just create a blank playground. And we're going to call this exercises. And I'm going to go ahead and paste in here the prompts for our exercises, okay? So they're going to get increasingly more difficult as we go. The first one, we are going to be using loops and comparison operators to print out odd or even numbers in a range. So I want us to write a function of some sort that's going to take in some sort of range of numbers and print out either odd or even numbers, right? So we're going to be able to give a function some range of numbers and then print out either the odd or even numbers in that range. And we're going to be using loops and comparison operators to do that. Next up, given an array of numbers, I want us to compute the sum, the maximum value, and the minimum value in that array or list of numbers. The next guy is going to be a little bit more complicated, and this is going to be a lot more similar to what we see when we start building mobile applications. So let's imagine you wanted to build like a guest list app. We're going to create a function to search for a user by name. So if you would imagine you have a security guard that's using the app and someone comes up and says, hey, I'm on the guest list. You want the security guard to be able to search for that person's name and see if they actually are on the guest list. And then we are going to create a function to get all users less than a certain age. So for example, if you're having a party, you want to figure out who can drink and who can't. So, or who's an adult and who's not, whatever it may be. And then we're also going to write a function to do things like update a person's RSVP status, get the number of users attending the party, get the number of users not coming to the party, and print out a report of our users, like the age, the number of people we're having, the number of people we're not having, so on and so forth. So that's going to be a lot of fun. Next guy is going to be creating a product and shopping cart array, or data structures. and we're going to write functions to apply a discount to an item, get the total cost of all of our products, and then print out a receipt. So this is going to give you guys an extremely good foundation for the problem solving and critical thinking skills that you're going to need to actually start building applications. Once we get into the app development stuff, once you have this foundation, it's really just going to be about building out your UI, and you're going to have all of the difficult stuff figured out already. So a lot of people will skip straight to doing the fun stuff and building the app, and then they have no idea how to do the actual programming. So that's why we're doing this here, guys. So let's go ahead and get started. Let's go ahead and create a section for our first problem, guys. And I'm just going to create a function to help us do what we're going to do, and it's going to be called print odd or even. So let's talk about what we want to do and how we're going to solve this problem and sort of the steps we're going to take to get there. So we want to use loops and comparison operators to print out odd or even numbers in a range. So there's a lot of moving parts here, right? And I want us to start really small and just print out the numbers 1 through 10. So I want you guys to try to pause the video and see if you can accomplish that without referring back to the loop section. So go ahead and pause the video and see if you can do that on your own. All right, guys, so you should have got something like this. Inside of our function, we're going to say for I in 1 up to 10, print I. Pretty straightforward. We've gone over this before. I represents the value of the iteration of the loop we're on within this range. So every time the loop runs, it's just going to print that. So it's going to start at 1 and go all the way up to 10. Let's just go ahead and say print odd or even to call our function. Run that guy, and we should get the numbers 1 through 10 as expected. Okay, so that's the first step, right? We're printing out numbers in a range. So the next step is, how do we determine if a number is odd or even? Well, mathematically, in order for a number to be even, we define that as it is divisible by 2. So any number that is even has to be divisible by 2. So by extension, any number that is odd is not divisible by 2. That's how we distinguish between odd and even numbers mathematically. So how do we translate that into code? How are we going to use logic and comparison operators to help us solve this problem? Well, if you guys remember, in our operators section, we have this modulo operator that gives us the remainder of the result of the division between two values. So we're going to be using this guy to help us determine if a number is odd or even. So let's go ahead and see how we're going to do that. So we need to introduce some logic here in combination with that modulo operator. So I'm going to say if I %2 equals 0, print number is even, else print number is odd. And let's see if we can print out the number as well. And then run our code again. So we see that number is odd 1, number is even 2, odd 3, even 4, odd 5, even 6. So this gives us the foundation of what we want, right? And sort of the mathematical reasoning behind that is anytime we look at I and say it's 4, if we divide that by 2, the remainder is going to be 0. And all that means is 4 divided by 2 results in an even division, right? There is no remainder. So it's 0. So that's how we determine if a number is even. And then else, the only other result we're going to get is the remainder will be 1, and that will indicate to us that the number is going to be odd. So we're just looking at I, and we're trying to get the remainder of the division between I and 2. If it's 0, we have an even number. If it's not, we have an odd number. So let's delete this else block really quickly, because right now we're just going to try to print even numbers. So we could say, damn it, sorry guys. I'm going to say print I. So now let's run this again, and you guys will notice that it only prints the even numbers for me. So the logic here is that if I %2 is equal to 0, we're going to print I, and we notice that it gives us back even numbers only. So next step, guys, is we want to be able to define whatever range we want in this problem, right? So right now we're just doing it from 1 to 10. What if when I call this function, I want to be able to specify the upper bound and lower bound of my range? So I could print the even numbers in any range that I want. So let's go ahead and try to figure out how we're going to accomplish that. So we're going to want to add an input parameter to this function so that every time we call it, I can specify the range when I call that function. So let's go ahead here and just say upper bound, and it's going to be an integer. And I can just replace 10 with my upper bound. And now when I call my function, it's going to ask me to supply it with that upper bound property. So you can hit that little red circle and hit fix, and it's going to pass that in for you. Now we could do like 100 here. And I could run this, and it's going to give me back all the even numbers from, 1 to 100. So next step, guys, is I want you to once again pause the video and see if you can make this a little bit more dynamic and supply a lower bound to our function as well, so that we can define a completely custom range of values that we want to print odd or even numbers between. So go ahead and pause the video, see if you can. Okay, so you should have been able to just follow the same pattern we used for the upper bound. So you're going to say lower bound, oops, and that's also going to be an integer. And now your function is going to look like this. So it's going to ask you for a lower bound and an upper bound. And we're just going to replace one with this lower bound guy. So our function is going to go, it's going to start at this lower bound, go all the way up to this upper bound, and it's going to print the even numbers in that range. So once again, you guys can just hit fix there, and it's going to pass that in for you. Swift is really handy with that. And let's maybe do it from 50 to 100, and let's see if this works. So you guys notice that we get all of the even numbers between 50 and 100 back. So now our function is really dynamic, right? We are printing out the even numbers from any sort of custom range that we want. So now I could go and call this again, print odd or even. It's going to ask me for an upper and lower bound, and I could say like 1 to 20. And you guys will notice here that it goes 2, 4, 6, 8, 10, 12, all the way up to 20, right? So that's really cool. And the last step of this, guys, is going to be to determine if we want to print odd or even numbers. So we're going to add one more input parameter here that's going to help us determine when we call this function if we want to print out the odd values or the even values. So let's go here, and we could say like show even, and this is going to be a Boolean property. Okay, so now our function is going to ask us for three things. It's going to ask us if we want to show the even numbers. If we say true, that means we print out even values. If we say false, that means we want to print out odd values, and then we will also specify the lower and upper bound. So here, let's go ahead and fix our functions. We could say show even true, and for this one, we could say show even false. And let's make the range the same. Let's make this both like 1 to 20. And let's add a divider so that we can distinguish between our function calls and our console. Okay, so now we have to add some logic in here, right, guys? So right now this is printing out our even values. So we only want to do this if show even is true. So let's go ahead and say if show even and else. So here, let me just add some comments. Print odd, print even. So now we could just take this guy and paste it into this if block, right? And then here, let's paste this. And we could replace that with not equal to 0, print I. So now we have the foundation for our logic here. Let's go ahead and see if it works. So the first time we print 2 up to 20, and the second time we print all of the odd numbers between 1 and 20. So this is looking really good, guys. So let's just give this a full breakdown. So basically we're saying, hey, if you want to show the even numbers, then you need to check to see if I%2 is equal to 0, and if and only if that is true, we print I. And then opposite of that, if show even is false, which is this guy right here, this else block, right? Then we are going to say if I%2 is not equal to 0, meaning it's going to be an odd number, then we print I. So this is combining a bunch of different concepts that we've learned thus far, guys. And I think we did a really good job of breaking that problem up into smaller problems and slowly solving each component. right? So we started off with just printing 1 through 10. Then we figured out how to print even values. And then we could specify a custom lower bound and a custom upper bound. And then we added the ability to show even or show odd numbers. So that just gives you guys an idea of what it's like to not only solve a problem, but how to translate a solution into a program. This is a skill we're going to work on over and over again, and it's the foundation of any good programmer. You have to be able to take a real life problem, solve that problem, and then translate the solution into code. And we're going to be getting a ton of practice with that. And in the next video, we're going to continue on with these exercises and go on to exercise 2. So that's going to be a lot of fun, guys. We'll see you there. Peace out. What's going on, guys? Welcome back. Hope you're doing well. We're going to be getting started with exercise 2 in this video. So if we go back to the prompt, we're going to be given an array of numbers and we want to compute the sum out of all of the numbers in that array. So we just want to add them all up and see if we can get the total sum. This would mimic something like a shopping cart where you would have to go through and look at all the items and get like a total price, right? And then we want to find the maximum value and minimum values inside that array. So we want to find the highest number and the lowest number in that array. So let's go ahead and get started. So down here, guys, I just created marks for each one of our future problems. You guys should go ahead and do the same. And I want us to just go ahead and create an array of numbers that we're going to be working with here. So I'm going to say var nums equals 1, 5, 6, 4, 1. And we're just going to write a function here to compute the sum. And we're just going to be working with this guy here. So we're also going to want to return a value, guys. So we're going to say this is going to be an integer. And let's just go ahead and return 0 for now so that our compiler doesn't yell at us for not returning a value. So let's talk about the goal that we have here. We want to obviously just get the total sum of all of these values. So it would be 1 plus 5 plus 6 plus 4 plus 1, which is 17. So we have to think about how we're going to do this, right? So ultimately, we're going to want to use a for loop and sum the values up as we go. But there is a little bit of trickiness involved here. And I have actually developed like a sort of visual representation of what this is going to look like before we get started with the code, guys. So I want to give you an idea of what the solution is going to look like, how we're going to be utilizing a for loop to do this before we get started with the code. So let's go ahead and just take a look at our array of numbers. So this is what we have here. So now let's talk about the first step of our solution. So we are going to create a property called sum that we will use to keep track of the sum at each point in our loop. So we're going to sort of treat this as like a running sum, right? So it's going to start off as 0, and then we're going to start here at 1. We're going to add that to our sum, and then our sum at that point would be 1. And then on the next iteration, we're going to make sum 1 plus 5, which is 6. So up to this point in the array, 1 and 5, our sum is 6. At the next iteration, it would be 6 plus 6, which is 12. At the next iteration, it would be 12 plus 4, which is 16, and then 16 plus 1, which is 17. So here's what that's going to look like. So we're going to start off with our for loop at 0. And the sum was previously 0. Sum is equal to 0 plus 1. So right now, at this point in our loop, the sum would be equal to 1. And then we're going to go to the next iteration in our loop, where we're going to be looking at 5. So if you guys remember, the sum was previously 1 at that point. And then we're going to say sum is now equal to 1 plus 5, which is equal to 6. And then at the next iteration of our loop, when we're looking at the 6, our sum was previously 6. So now it's going to be 6 plus 6, which is 12. And then I think you guys probably get the hang of this now. When we're looking at 4, the sum up to that point was 12. We add 12 and 4 to get 16. And then finally, we are going to get 16 plus 1 equals 17 to give us the solution to our problem here. So let's go ahead and hop into the code now to actually write this out. So we're going to create this sum property, right? And it's going to equal 0. And this is actually just going to be a couple lines of code to solve this problem, guys. But we're going to add some print statements so we can see what it looks like along the way. So I'm just going to say for num in nums. And you just have to say sum plus equals num. And then we just return our sum. So this is literally all you have to do. So this is pretty slick right here. So basically, our sum is going to start off at 0, and at each point in our loop, at each number value, we're just going to add whatever that number is to what the sum is at that point. So it starts off as 0, and then our first value is 1. So then sum becomes 0 plus 1, which is 1. And then at the next point, sum is now 1, and then we're looking at 5. So we're going to say sum is equal to 1 plus 5, which is 6. Now, if you guys remember, this is our compound assignment operator. So this is equivalent to sum equals sum plus num. So we're taking a look at the existing value of sum, and we're setting it to be that value plus whatever number we're looking at. So I'm just going to go ahead and add some print statements here, guys, so we can get a better idea how this is working. So I'm going to say print sum before addition is sum after addition is sum. So we're going to print the sum out before we add anything to it. Then we're going to do that add operation, and then we're going to print it afterwards. And then ultimately we're going to return that sum. So let's go ahead now and just say compute sum and run our code. So we see sum before addition is 0, and then it's 1. And then before addition, it's 1, and then it becomes 1 plus 5, which is 6. Then it's 6, and then it's 6 plus 6, which is 12, so on and so forth, just like we went over in the diagram. So just to do another quick recap of everything that's going on here, the key to this problem is really creating this sum variable. And this gives you guys some more insight into how we can use variables effectively to solve problems when we're programming, right? So this is just going to store some information about our sum. And as we go through the loop, we're just going to modify this variable as we go. And it's always going to be equal to the sum up to that point in the array. So this sum guy, it starts at 0, and then like once we're at 4, this will be equal to all of the sum of all of these things, because we're just adding to it as we go. And the beauty of the variable here is that it keeps track of that as we go. It's something that we can use to keep track of information as we go throughout some sort of process. So that's a really awesome problem there, guys, to help give you an understanding of how we can use loops and variables together to solve a problem. And finding the min and max values are going to be very, very similar to this. So we're going to get some more practice with this right now. So let's just go ahead and say func compute max, and it's going to be an integer. So same thing with our very similar concept to how we solve this. We're going to create another variable here to keep track of our maximum value. And as we go through our array, we're just going to check to see if the value we're looking at is greater than the existing maximum. And if it is, then we will update the max. If it's not, we just do nothing. Okay. So let's go ahead and say var max equals 0. And we're going to loop through this once again. We're going to say for num in nums. And we're just going to say if num is greater than the max, then literally all we have to do is say max is equal to that number. And if it's not, we just don't do anything, right? And we can ultimately just return our max. So let's go ahead here and say compute max. And obviously, guys, this should give us back 6. So let's go ahead and see what that gives us back. And we notice that this gives us 6 right here, like on that little right side menu. So let's talk about this one really quick. You guys notice that these solutions are happening pretty quick, but I am going to go through them in detail as we go. So basically, we're doing something very similar to what we did up here. We're just creating a max property. And like I said, this is going to keep track of our max as we go through the array. So basically, we have to look at every item in this array, compare it to this maximum value, and update it as we go, right? So right now it's 0. So when we get to 1, it's going to say, hey, is 1 greater than 0? Yes. Okay, now the new max is num, or sorry, 1. And then we get to 5. And then it's going to say, hey, is 5 greater than 1? Yes. Okay, so now the new max is 5. And then we get to 6, and the same thing happens. It updates the max to 6. But then when we get to 4, this is where it gets interesting. We're going to say, hey, is 4 greater than 6? No. So it just totally skips this if statement and continues through our loop. It then goes to 1, and it says, hey, is 1 greater than 6, which is what our max is at that point? No. Okay, we're done with the loop, and then we just return that max property. So we are just updating this guy as we go through the loop. So once again, I'm going to add some more print statements, and then I want to see if you guys can accomplish this for the minimum value problem. So let's see, we'll say print max is max. We could say, let's say current max. And then here, after we update it, we'll say print new max is max. And make sure you do that after you update the max value property, guys. You could even just go here and say num. Okay. And to really understand what's going on every step of the way, let's go ahead and add an else block here, guys, and say print num is not greater than max. So the reason I'm doing this here is because we want to see what happens when the max doesn't update, right? So that's what's going to happen in this else block. Once we're done going through the sort of flow of this program that we're writing to compute the max, we can delete this. But let's just go ahead and run this now, guys, and see what the print statements that we get back look like. So as you can tell by now, print statements are a great way to understand what's happening in your program step by step. So let's go ahead and check this out, guys. So we see that we get to this print statement once we're inside of the for loop, right? And we notice that the current max is 0, and that's because we set it to 0 to begin with. And then we go through this check. We say if num is greater than max, so 1 is greater than 0, because we're looking at 1 for the first value of our array, right? Like 1 is right there. Then it's going to say, okay, now your max is equal to 1. So that's why we see new max is 1. And then on the next iteration of the loop, current max is now 1, and the next value in the array is 5, so it should say new max is 5, because once again, we go down this if path, and it says, okay, 5 is greater than 1, so the max is now equal to 5. And then same thing happens when we do 6 and 5 comparison. And then the next step is interesting, right? We see that the current max is 6, but now we are looking at 4. And after that, we're going to be looking at 1. So what's going to happen there is this is going to say, hey, is 4 greater than 6? And the answer is going to be no. So that's when we go here and we say num4 is not greater than max 6. So we never update the max there. You guys notice we're only updating the max in our if block, because that's when the number that we're looking at is greater than the maximum value. So the same thing happens when we go and check 1. We see that num1 is not greater than max 6. Now the loop is completed, and we have gone through all of the elements in the array. So we exit this loop here, and we ultimately return our max, which is why we get back 6. So very similar to our sum problem there, guys. It's a little bit easier if you ask me. And that just illustrates that same concept of like, hey, we want to find out something about an array that we're looking at. We have to go through each item in the array. We use a for loop. We add some comparison logic in there to update some values and ultimately get back a result. So next up, guys, I want to see if we can accomplish computing the minimum value. So if we go back to our prompt, we also want to find the min value of our array, and we're going to write a function to do that here. So I know I said you guys could try to pause the video and try to do it yourself. So if you want to do that, go ahead and do it now, and then come back to this. But if you want to just watch me do it, then let's go ahead and get started. So we can write a function called compute min, and it's going to return an integer. Okay, so we have to set this up a little bit differently than we did with our max variable. So basically the logic is going to be the same, right? We're just going to create a minimum value property that's going to keep track of the min as we go through the array, but we have to set it up a little differently, as I said before. So here's what would happen if you tried to do it the same way we did it with the max guy. We could literally just copy and paste this, or let's clean this up. We can leave it as is for you guys to sort of better, like leave those print statements in there. It'll help you guys in the future. So let's go ahead and just copy and paste all of this code. And we want to just change this logic up a little bit, right? We don't need our else block. And we would basically say if num is less than max, or sorry, if num is less than min, min equals num, print new max is, or new min is num. Okay, let's see. Let's run this and see what happens, guys. Compute min and run. We're going to get back that it's just 0, right? And that's because we're initializing this thing to 0, and nothing is ever less than 0 in our array. So every time we go and check one of these values, it's going to say, hey, dude, like 1 is not less than 0, so we never update the min because we're initializing it to 0. So we have to be a little bit more crafty with how we initialize our initial value for that minimum. So what you can do is you can either set it to like the first number in the array. So let's see, we could say equals nums 0. But this is not the greatest thing to do. What you'll see a lot of the times is people say int.max. So this is the highest number that our compiler will allow us to use in Xcode. It's like some ridiculously big number, but typically numbers aren't allowed to get bigger than this number because of memory issues, right? So when you say int.max, let me just go ahead and say print min is min. And let's go ahead and compute our minimum value. Right, this is the largest number that you can have in a program. And like I said, numbers can't get larger than that because your program would have trouble storing that in memory. So why do we do that, guys? And well, it's because we want the minimum to start off as the largest value possible so that we can check all values less than that value, right? So similarly, if our max, or if our numbers guy here could have contained negative values, then we would have wanted to start off our max at the lowest possible value that we can have. But we're just assuming that this has no negative values. So this is typically what you'll see for programs that are trying to find some sort of minimum. You start it at the biggest value that you possibly can, and then go through the rest of the program, right? So its current max is 900 zillion whatever, and then it's going to say, hey, 1 is less than that, so update the min to 1. And obviously 1 is our smallest value, so ultimately we get back 1 for this compute min function. So that's going to wrap it up for this exercise, guys. I hope you didn't get too lost in the sauce there. Basically, the concept behind what we're doing there is looping through an array of values and figuring stuff out as you go through that loop, right? That's a very, very common concept in writing computer programs and building apps and stuff. You're going to have arrays of things, whether it's like a shopping cart, like this example kind of mimics, right? And you want to get the total for the user, or maybe you want to get the most expensive item in the shopping cart, or maybe you want to get the cheapest item in the shopping cart, stuff like that, right? This is sort of how you would accomplish that, and that's the logic and the reasoning behind it. So this stuff is going to be hard at first, right? Thinking like a programmer and having to solve problems in this way is difficult. It's like you're learning an entirely new language. But as with anything, the more you practice, the better you're going to get at it. If you're just starting to learn a new language, you need to completely immerse yourself in it, and it's going to be confusing at first. But as you start to go through and the motions more and practice it more and do more examples, it's all going to start to come together very slowly. So if this is still really difficult to you, that is totally fine. Like I said, we're going to get so much practice throughout the rest of this fundamentals course and our app development course and all of the other courses that I have available to you guys. So don't worry. You guys are doing absolutely phenomenal so far. This stuff is not easy, and we are going to be moving on to our next exercise, which is going to be a lot of fun. Get excited for that, guys. We'll see you there. Peace. What's going on, guys? Welcome back. Hope you are doing well. In this video, the third one of our exercises module, we're going to be going over problem 3. So let's take a look at the prompt and talk about how we're going to solve this problem and then dive into the code. So we are going to imagine that we're building sort of a guest list program or application. And we want it to have all of these features. So we want to be able to search for users by name. So if you were to imagine a security guard with this app, someone comes up to him at the door, says, hey, I'm on the list. You have to be able to search for that person and verify that they're on the list, right? And then continuing on, we maybe want to look at all of the users less than a certain age so we can determine who's an adult, who can drink, blah, 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 blah. Update our RSVP status of users so they can say, hey, I'm coming, hey, I'm not coming. Get the number of users attending the party, by extension, the number of users not coming to the party, and then maybe print out some sort of report. Hey, X amount of users are coming, X amount of users are over 21, blah, 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 blah. So let's talk about how we're going to solve this and how we sort of want to structure our code to accomplish this in the most efficient way possible. So first thing that I see when I look at a prompt like this is we're going to want to create some sort of user, right? And we want to look at the properties that that user is going to have. So we know that each user is going to have a name, each user is going to have an age that we need to look at, and then maybe some sort of RSVP status. And that could be like a Boolean variable, right? Like attending, yes or no. So let's go ahead and take a look at what that would look like in this diagram here. So this is the sort of the first thing I would want us to do. So oops, one sec, guys. So our guest would look like this. It's going to have these three properties. And then this is what it would look like programmatically. We're going to create a structure. It's going to be a guest. And then it's going to have name, age, and is attending, which will be a Boolean variable. So we'll be able to keep track of which users are attending the party and which are not, which users have what age and their name. So that's going to help us solve a lot of those initial problems, right? Searching for a user by name, filtering them by age, updating who's coming and who's not, getting the amount of people that are coming and that are not, and all of that stuff. But I want to take this a step further, and this is where this gets interesting, right? So we have a bunch of guests that we're going to have at the party, but we also want to have a guest list that's going to contain a bunch of those guests, right? Like that makes sense. The guest list is going to contain a bunch of guests, and each guest is going to have this set of properties. So we're also going to get a little crafty here and create this guest list structure. And it's just going to have one property, and it's going to be an array of all of our guests. So this is ultimately going to be the foundation of our program, guys, and the solution to the problem that we are trying to solve. And I always like to take some time to think about how I'm going to solve my problem and write my code before I just start writing code right away. So this is something that is very similar to what you would see from like a client. They would write you this list of requirements for an app they would want you to build, and your job is to figure out how to architect a solution to do that. Ultimately, this requires a lot of practice, which is what we're getting now. As a beginner, you guys would not be expected to architect a solution in this way, but we are going to start going through how to solve all of these problems now, and you're going to see that the data modeling that we did and that foundation that we just laid is going to help us work through these solutions in a much more effective, much cleaner, much more professional way. So let's go ahead and get started with our code, guys. So let's just go ahead and create those two data structures. So we want one for our guests and one for our guest list. So we're going to say struct guest. And if we look back at our code or diagram, it's going to have a property to determine whether or not they're attending, their full name, and their age. So let's go ahead and do that. So we're going to say let name string, let age int, var is attending, bool. And let's go ahead and break this down a little bit, right? Because the distinction between let and var is important to understand here. So obviously someone's name isn't going to change, right? So we can make that a let constant. Someone's age, for the purpose of this program, we're just going to assume is not going to change either. And this guy here is going to be mutable, however, right? Like we're going to ultimately want to be able to modify whether or not a user is attending. So this property can change between true and false. And you definitely want to make this a Boolean because, someone's either going to be coming or they're not. So that has two potential states. It's either yes or no. Anytime you have something like that, you're going to want to use a Boolean property to do that, okay? So that's our guest struct. And once again, this is a variable because ultimately that will be able to change at some point. The other two properties will not. They are going to remain constant. And then here is where this gets a little bit more crafty, right? We're going to create this guest list structure, and our guest list is just going to contain a list of guests. Okay, so here's how you model that out programmatically. We're going to say var guests, and it's going to be a an array of guests. And I'm just going to go ahead and paste some code in here, guys, for creating a bunch of different guests. And let me see, make that G6. You guys should pause the video. Just go ahead and do the same. So ultimately, the structure here is we're just going to create a bunch of guest objects so that we can ultimately add them to our guest list. Awesome. So now let's hop back up to our prompt to see what the next step of this is going to be. So we want to create a function to search for users by name. So guys, I want us to try to figure out where we're going to put that function. Okay, so let's think about that. You would want to be able to search for a user on your guest list, right? So we should make this function a struct function that's part of our guest list so that we can say guest list dot search for this user. Okay, so let's go ahead and write a function to do that. So we could say func search for guest, and it's going to be a guest, and it's going to return a Boolean variable, right? And why is that? Well, because ultimately we want to know if that guest is on the list or not. So if the guest is on the list, we return true. If they are not, we return false. So let's go ahead and figure out how we're going to accomplish this. Well, ultimately, what we're going to have to do is search through our array and see if the user's name is equal to the name that we are searching for. So we're going to use a for loop to do that. And the reason that we're writing this on our guest list guy is because this is where we have access to that array, right? We can search through this array of guests and try to find the user that we're looking for. So let's go ahead and actually modify this to just be a name and make it a string. So this function will just pass in some sort of name, and then we'll be able to determine if the user's on the list or not. So let's say for guest in guests, right? So this is the start of our loop, and this is going to loop through each one of these guys. So basically, we just need to check if the name we're passing in is equal to the guest's name. So we're going to say if name equals guest.name, return true. And something that you guys might think to do is say else, return false. But this would actually be wrong. And let's go over why. So if you guys remember, anytime you say return in a function, the function stops there and it returns that value. So let's imagine we're searching for Katie Smith right here, and we go to the first item in the array, and it's going to equal Bruce Wayne, right? So it's going to say, okay, we're looking at Bruce Wayne. The name is not equal to the one we're searching for, and then it would hit this else block and it would just return false. So if you set your program up this way, unless the first guest was equal to the one you're looking for, it's always just going to return false. And that would give you a big problem, right? Because your program would just not work at all unless you were searching for the first guest on the list. So how do we accomplish this? Well, we want to make sure the loop completely finishes before we return false. So here's the logic behind this. We want to check in each user and see if they're on the list. And by the time we finish, if we never find them, then we can return false. So we want to wait for this loop to finish, which is after this bracket. And now we can just return false. So once again, guys, this is very important to understand. We only want to return true if we find the user, but we also want the program to search through the entire list of users, right? You have to guarantee that you are finished searching the list before you can definitively say someone is not on it. So that's why we return false after the loop is done. And if somewhere within that for loop, we find the user, then we return true. So let's imagine we were searching for Tom Johnson. It would start at Bruce Wayne. This if would fail, and then it just goes to the next iteration of the loop. It just sort of continues on. And then it goes to Heath Ledger. Okay, that's not what we're looking for. And then it gets to Tom Johnson, and it says, oh, hey, found him, return true, and then it stops there. Okay, so let's add some print statements to show you how that's working. Print searching, print found guest, and then here, let's say print could not find guest. And let's go ahead and run this. So let's go ahead and say guest list dot search for guest, and let's pass in Tom Johnson. And guys, make sure that this is case sensitive. So, the search will be case sensitive, so you have to make sure that you capitalize things correctly. We can go over how to solve that in just a little bit. Okay, so we see that on the first iteration, we're searching, right? And then on the second iteration, we're still searching with Heath Ledger. On the third iteration, we're searching and we enter the if block, we say found guest, and you guys see that no more print statements execute, even though there are 1, 2, 3 more guests, because we return true as soon as we find that name. So if you guys were to want to avoid, let's say, for example, I forgot to capitalize the J in Johnson, we're going to notice that it searches through the entire array and then ultimately says could not find our guest. And that's because this stuff is case sensitive. So what we can do is just lowercase everything. So we can say if name.lowercase equal guest name.lowercase, then, we'll notice that we found our guest. So basically this dot lowercase little function here is an extension of a string, and it will allow us to just lowercase the entire string. There's also uppercasing and all that stuff, but we're pretty much just flooring everything to be a lowercase value so that our search doesn't have to be case sensitive, which makes our program a little bit more bulletproof, right? So this just gives you guys an idea of the type of things you have to deal with as a programmer and the type of problems you have to solve. So let's keep going, guys. Next up, we want to create a function to get all of the users less than a certain age. So let's break this down a little bit. We're going to be creating a function, so we know that, and we want to get users. So anytime I see get and then something else like get a user, I'm going to write a function that I want to return a list of users, right? So we want to get all of the users that are less than a certain age. So let's go ahead and figure out how to do that. And once again, this is going to be on our guest list struct because we have to search through this array. And you guys can see here the utility in that, because we can just call this function as an extension of our guest list object. So that's why I like to encapsulate it. You'll hear that term a lot, or contain it within this data structure, because we only want this function to be available through my guest list class or structure. So, all right, guys, next up, we're going to say func get users less than age, and we need to pass in an age here. And this is going to return an array of guests. Sorry, I was calling it user there. So this is the foundation for this function, right? If we go back up here, we see that we want to create a function to get users that are less than a certain age. We don't know the age that we're going to pass in at the time, so we're making that an input parameter so that we can pass in any age that we want. So let's go ahead and do this. We're going to create a separate array, call it results, and it's going to be a blank array of guests, and we're just going to return this result. So basically, guys, since we want to return a list of users, we're going to create that empty array here, and we are going to go through and loop through all of these users and add things to this list as we go. So let's go ahead and say for guests in guests, and then we're just going to, this is pretty simple. We're just going to say if guests guest.age, is less than or equal to age, results.append guest. Okay, and then similarly, we could write another function to get all of the users over a certain age, but that can be a bonus for you guys if you want to do that. The logic is basically the exact same. We would just replace this with greater than or equal to. But let's go ahead and say let guests under 21 equal guest list dot get users less than age 21, and let guests under 18 equal guest list dot get users less than age 18. And let's go ahead and run this and see what this guy gives us back. So we see that we have 2 users that are less than 21, and we have 1 user that is less than 18. So that should be pretty straightforward, guys. The concept here is that we just have to loop through each one of our guests and check the age property, cross-reference it against this age we're passing in this case 21 and 18, and then we have this result array that we're going to return from this because we ultimately want to get back the users that are less than that age. And if we meet this criteria, we append the guest to this array and ultimately return that array. So this will give us back all of the users less than a certain age. And you can see the utility of it here where we can pass in any age we want, right? So next up, guys, what I want us to do is see if we can get the number of users attending and the number of users that are not attending the property or the party, sorry. So basically what we want to do is once again, go through this array, and if we see that is attending is true, we want to count all of those users and ultimately return the number of users attending. So we're going to return a number here, and very similar to what we're going to do with the opposite, we're just going to look at all of the users that are not attending and count up all of those guys. So let's go ahead and write a function, say func get number of attendees, and it's going to return an int, and another func for get number of guests not attending, and it's going to be an int. So a couple different ways of doing this. Let's go ahead and just start with this function. We don't need to pass anything in, but basically what we're going to do, guys, is just loop through the array, and we are going to say that, hey, if is attending is true, add some number, add 1 to like some sort of count, right? So we need to keep track of a count as we go through this array. So we're going to probably set it up to 0, right? So we want to start at 0. And then each time we go through a guest in that array of guests or list of like our guest list, we're just going to check and see if they're attending the property or the party, sorry. And if they are, we just add 1 to the count. So this is what this is going to look like. Let's just break it down. We look at guest 1, they're not attending, so we do nothing. Guest 2 is attending, so we add 1 to our count. And at this point, our count would be 1. And then guest 3 is attending, so we want to do 1 plus 1, which would get us 2. And then false, true, true, so on and so forth, right? So we're just going to create a variable for our count here. It's going to equal 0. And then we're going to say for guest in guests, if guest dot is attending, count plus equals 1. And if you guys remember, this is equivalent to count equals count plus 1 with our compound assignment operator. So once we get here, it does nothing. And then it goes to the next guy, and then it will update our count to 1. And then once it goes here, count will be 1, and it will then say count is now equal to 1 plus 1, which is 2. Gets here, does nothing. Gets here, count is now equal to 2, so then count equals 2 plus 1, which is 3, and then count equals 3 plus 1, which is 4. So we have 4 people attending our party, and then we just return our count here, guys. So that's that, and let's see like how we would do this. You guys could obviously set it up the exact same way. So we could simply just copy and paste this, and we would just negate this, right? So we say, we use this exclamation point to negate that is attending guy. That's how we check to see if it's false. So we say if guest dot is not attending, right? So is attending and then negating that property. Then we increment our count and return that count. Okay, so that should be good. Let's go ahead and try this out. Let's say let num attendees equal guest list dot get number of attendees. Let not coming equal guest list dot get number of guests not attending. And let's run our program once again and pay attention to this right side menu. We have 4 people coming and 2 people are not coming. So that looks really, really good. Now, guys, let's ultimately just see if we can accomplish that last piece of the puzzle here, where we want to just print out a report about all of the users that are coming and not, and over a certain age and not, and just, you know, write some sort of function to print all of that stuff out so we can get like an overview of our party. So within our guest list structure, guys, let's just go ahead and write a function to print our report here. So we're going to say func print report, and I'm just going to paste in some notes I have about what we're going to be printing out. So we want to get the number of people coming, the number of people not coming, and the number of people not allowed to drink. So let's just go ahead and add some print statements in here. We're going to say print there are, and we'll do some sort of string interpolation, which we'll come back to, guests attending. And let's copy this, paste that in there, guests not attending, and just copy that, and we could say print there are some number of guests not allowed to consume alcohol. Okay, so let's go ahead and now figure out what's going to go into these string interpolation parentheses. So what we can do, guys, is access these functions directly now because we are still within this guest list struct. So you guys would notice that before, when we wanted to access those functions, we had to do it through an instance of our guest list. And if you remember, creating a guest list is referred to creating an instance of that guest list. And then because these are functions that are on the guest list object, we can only call them when we say guest list dot. Or if we had like multiple guest lists, maybe we could say guest list 1 dot get users less than this, guest list 2 dot get users less than this, and they would be different guest lists and blah, 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 blah. We can go over an example of that in a little bit. But now, because we're still inside of the structure, we don't have to access it through an instance. We have direct access to these functions. So I could say get number of attendees. And like I said, this is what it looks like to just call it directly because we're inside of this structure. And then here we could say get number of guests not attending. And here, let's just go ahead and put 0 in here for now to get rid of that error. I want to go ahead and say guest list dot like print report. So let's get rid of all of this stuff here. And we could say guest list dot print report. And let's go ahead and run this. And we can see there are 4 guests attending, there are 2 guests not attending, and that there are 0 guests not allowed to consume alcohol. So let's go ahead and fill in this last block. I just wanted to show you guys sort of what printing the report would look like and how we call it, and the difference between what we see here versus what we see here, where we call functions that are through an extension of an instance of the object versus calling those functions directly when we're inside of our guest list struct. So anywhere outside of this thing, if I want to call those functions, I have to do so through an instance of the object. So now what I can do here is say let guests under 21 equal get guests, what was that function called? Less than age 21. And here, this will give me back the actual guests, guys. So I want the number of guests associated with that. So then I could say let num guests under 21 equal guests under 21. And you guys will see here in your autocomplete window that this is an array of guests. I can just say dot count. And you guys can see here that this gives me back the number of elements in my array. So dot count will always just give me back the number of items in that array. So now I go ahead and replace this guy with num guests under 21. And let's go ahead and print my report once again. 4 guests attending, 2 guests not attending, 2 guests not allowed to consume alcohol. right? So that's looking really good there, guys. And really quickly, something I've done to illustrate a concept to you guys is create like another set of guests and another guest list object. This would be referred to as another instance of a guest list. So this is one instance, this guest list here. This is a separate instance that contains a separate list of guests. You guys will notice that I can call these functions on each individual guest list, right? So I can print the report for guest list 2 and print the report for guest list 1, and it will give me back different things that correlate to the guest list that I'm calling the function on. So you can see here that here I have 4 guests attending, 2 not attending. Here I have 5 attending, 1 not attending, and everyone's allowed to drink. Here 2 people are not allowed to drink. So this illustrates the benefit of these like class level functions, guys. Or like data object functions that we're using. And what I mean by that is all of these functions that are part of this struct here. So basically, I can call the same function on a separate instance, and it will give me back the information relative to that particular instance, right? So this is guest list 2, and this has its own data, right? And this is guest list 1, and it has its own data. So when I call print report, it will go through and use all of these helper functions that I have inside of my struct, and it will give me back the data in accordance with that particular guest list. So that's a very important concept to understand here. You guys are doing so great. This stuff is not easy. This is actually getting into some pretty high level programming here. So if it's difficult to wrap your head around this stuff, don't worry, guys. This is really going to start to come to life in the app development course. Once again, I'm just giving you guys the foundation you need to succeed once we get there. So you're getting the hard stuff out of the way first. Anyway, guys, now that we're done with that problem, let's go ahead and move on to our product problem. And it's going to carry over a lot of the same concepts we just did here. So this one should be a little bit easier, and you guys will get to see another example of how all of this stuff works together. So get excited for that, guys. We will see you there. Peace. What's going on, guys? Welcome back. Hope you're doing well. In this video, we are going to be solving the final problem in our exercises module and ultimately wrapping up this fundamentals course before we move on to the app development fundamentals. So this is exciting. Let's go ahead and talk about the problem here, and then we're going to talk about how we're going to solve it, and then we're going to hop into the code. So we are going to be creating a shopping cart here. And the idea behind it is we want to be able to add and remove products to and from our cart. We want to be able to apply individual discounts to items, and we can apply both dollar and percentage discounts. And then we are going to want to be able to get the total cost of all of our products and then print out a receipt. So this is very similar to functionality you would see on any sort of app or website that has a shopping cart as a part of it. Something like Amazon or any online shopping website is going to have functionality very similar to this. And in terms of how we're going to solve this, guys, I have a visual breakdown of how we want to structure our data, but it's going to be very similar to our guest list problem, where we have an individual item and a list, another structure that is going to contain a list of those individual items. Before it was guests and a guest list. Now it's going to be a product and shopping cart. So before we hop into the code, let's go ahead and see what this is going to look like in a visual diagram so we can figure out how we want to model our data and structure our solution to the problem here. So we are going to be creating like a product data structure, and this is just going to be pretty simple. It's just going to have a price and a name, like MacBook Pro, $1,300, right? And then what we want to do from there is we want to create another data structure that is going to contain a list of these products. So that's going to look like this. We're going to have a cart data structure, and it's going to be, a shopping cart that contains a list of all of those individual products. So let's go ahead and hop into Xcode now, guys, now that we have a sort of breakdown of how we want to structure our data, and then we can start diving into each individual line item and figuring out how to solve that. So let's scroll down to problem 4. We don't have a problem 5, so I'm going to delete that. And I want you guys to actually pause the video and see if you can figure out how to structure this data. Very similar to what we did with our guest list and guest structures. See if you can do that for our product and shopping cart structures. All right, guys, so let's go ahead and see if we can model out these data structures. So we're going to create a struct for our product, and then we're also going to create a struct for our cart, okay? So this is something, this should be similar to what you have if you tried this out on your own. And if you guys remember, our product is going to have two properties. It's going to have a name and a price. So let's go ahead and do that. We're going to say let name, and that's going to be a string, obviously. And then we're going to create a price, which is going to be a variable, and it's also going to be a double data type. So the reason this is a variable, guys, if you think about this, we want our price to be able to change. We might apply discounts to products later on, right? So we definitely want that price to be mutable or changeable. And we definitely want it to be a double so that we can have decimal points on our prices, right? Something could be $5.99, so that we definitely don't want to just make this integer values, right? We definitely want to make this a double data type here. And then our cart should be pretty straightforward as well. It's very similar to our previous problem. We just want our cart to have a list of products. So we can go here and, we could call it items if we want. You could call it products if you want. It doesn't really matter. It just needs to be an array of products. And it is very important that we make this a variable as well, because we are going to be modifying this list. We're going to be adding things to it, removing things from it, applying discounts to items inside of that list, so on and so forth. So this is sort of how you should have structured your data, right? So now that we've done that, we can proceed with how we want to solve each individual line item for this problem. But it is very important to, like I said before, figure out how you want to structure your data and sort of model that out, so that it makes solving the rest of the problem very easy, right? So we have a really good foundation here with our data structures. So now we can move on to the individual line items for solving this problem. So the first thing we want to be able to do is add items to our cart and remove items from our cart. So we want to create two functions to help us do that, right? One for adding an item and one for removing an item. But we should also think about where we want to place those functions. So if you guys are thinking about this in the right way, you would realize that we should place that on the shopping cart structure, right? Not the product structure, because ultimately we are going to be adding products or removing products to this list here. So we only have access to this list inside of our shopping cart struct. So if we want to add things to it or remove things from it, we have to be within this data structure. So let's go ahead and create two functions here. We're going to say func add item, and it's going to be a product. Func remove item, and it's also going to be a product. Okay. So the first one should be pretty simple, but there is something a little bit tricky attached to it that we're going to talk about in just a second. But it's pretty simple, guys. We just want to take this item that we're passing in and then append it to this array here. So we're going to say items dot append product. So this little tricky thing I'm talking about is going to show up right here. So you guys notice that we get an error. It says cannot use mutating member on immutable value. Self is immutable. What in the heck does that mean? So with structs, guys, you can't modify things in that struct directly unless you add this mutating keyword to your function. So basically, structs are treated as a certain type of data structure that you can't modify or mutate within the struct itself. So basically that's what we're trying to do here, right? We're trying to modify this items property from within our data structure with this function. So if you want to be able to do that, you have to add this mutating keyword there. Something else that we're going to talk about in our fundamentals part 2 course after we do the fundamentals of app development part 1 is the difference between structs and classes. So another way to create a data structure is to make it a class, and classes are treated differently where you can directly modify them without using this mutating keyword, but we're going to talk about that in a separate course, right? I want to keep things as simple as I can for you guys because a lot of this coding stuff can obviously be really overwhelming. So just know that if you want to change anything within your struct from like a function like this, you need to make it mutating. And we need to do the same thing for our remove item, mutating func remove item. So let's think about how we want to remove our item from a shopping cart, guys. Well, basically, we're going to pass in some product that we want to remove, and we have to go through and search this items array and see if we can find it and then delete it. So let's go ahead and figure out how to do that. I'm going to show you guys 2 different ways of doing it. The second one being much more concise and much cleaner. But I do want to show you the first way because the concepts are the same. Swift just has a nicer way of letting us do this. So we're going to use a for loop here, right? We want to be able to loop through all of our items and search for the one that we pass in here that we want to remove and then remove it from the array. So I'm going to say for I in 0 up to items.count. And this is going to start my for loop, but you guys notice that we're using the index here. And this will come into play in a little bit. Then we want to say, hey, if the product name is equal to the one we're searching for, then we know we found the guy that we want to remove. So let's first off say let product equal items I. So this will give us access to the product that we're looking at in the array. Let's call this item actually, so we don't confuse these two things. And then we need to say if item dot name equals product dot name. Let's do and item dot price equals product dot price. Then we're going to say self dot items dot remove at I. So this is where this index property comes in, guys. So some of you might have tried to do it this way for product or for item in items. And then you can have this logic in there as well, right? If item.name is equal to, let's delete that really quick. This checks if the things are equal, right? The thing we pass in that we're trying to remove, is it equal to the item that we're looking at and that particular iteration of the loop? Well, then what do you do, right? Ultimately, you have to say remove at and then give it an index. Well, here we don't have access to an index. We're just going from item to item. So that's where this index property comes in. We are looping through a range of indices here, and that way we can access the item that we want in this array through that index property when we find the correct thing. So that is pretty important to understand there. But anyway, that's our remove item guy. Next up, we are going to want to be able to, let's do this guy, get total cost, and then we'll do discounts, and then we'll do print receipt. So let's write another function here to just get the sum of all of our products. So we want to say func get total, and this is going to return a double. And once again, guys, this should be placed on our shopping cart data structure because we ultimately need to loop through this items array and sum up all of the values in there. And we have done something similar to that already in one of our problems where we, this guy up here, where we computed the sum and computed the max and all that stuff, it's going to be the exact same concept, right? So we're going to create a variable to keep track of our sum. So we're going to say like var result equals 0.0. So our compiler knows that this is a double because we ultimately need to return a double. Then we're going to say for item in items. And here we don't really need access to the index or anything, right? We don't need to modify anything in our data structure here. So we don't need an index that we're looking at. We can just look at each item and add the price to this result guy. So we can say result plus equals item dot price return result. And that's it for our get total function, right? So if you guys remember, this keeps track of the sum as we go. And then at each point in the loop, we just add the item's price to that guy. And let's say the first item was $5 on the after the first iteration, result would be 5. Let's say the next item is $7, then it would become 5 plus 7 equals 12 to ultimately get us a total of $12. So that's getting our total. Next up, guys, let's see if we can figure out how to apply a discount to individual items. So this one gets a little bit more tricky, right? Because we have to figure out where we want to place this function. So the reason I said we want to apply that to individual items was to give you guys sort of a hint there. where it's like, okay, where do we want to place this discount function? Well, if it were me, I would put it on the product structure, because a discount is something that's going to be applied to an individual product, right? So we can say func apply cash discount and func apply percentage discount. Okay, so what we are going to do with these functions, guys, is when we have individual products, we'll then be able to say, hey, product1 dot apply cash discount. And we obviously need to pass in some sort of amount here, double, and then double. And we can, let's call this like maybe percentage for the percentage discount. Cool. All right, so now let's figure out how we want to do this. So basically, we're going to look at this price and we're going to modify it with, this amount here. So we're going to say self.price minus equals amount. And because we are modifying this price, guys, we also need to make this a mutating function. And once again, the reason for that is because this function is trying to modify a property on the struct, so it needs to be mutating. And then here, make that a mutating function as well. Let's apply this percentage discount. So we're going to say price, let's see, if we apply a 20% discount to something that's $10, right? We want the price to be $8. So let's just figure out the math here. So it would be times equals 1 minus the amount. So percentage. So this equates to 10 times 0.8 equals $8, right? So that's a little tricky with the math, but I'm sure if you guys think about it, it'll make sense. Basically, if you want to apply a 20% discount, the final price would be 80% of the original cost, right? So that's 1 minus the percentage right there. Okay, so that looks good. Now we can apply individual discounts to our products. Last thing we need to do, guys, is be able to print a receipt about all of this stuff. And then we're gonna, write up or do an example where we create some products and add them to a shopping cart and test out all these functions. So let's go ahead and do that now. So let's write another function here, and this one is going to go on our shopping cart because we need to look at all of the items and print a receipt about all of those items. So let's say func print receipt, and this is going to be pretty simple. It's just going to say print the total cost of your items is get total, and let's put a $sign in front of that maybe. And we could maybe modify this a little bit more later on once we apply some discounts and stuff. But what I want us to do now is I'm going to pause the video and just go and create a couple products, add those products and use those products to create a shopping cart. And that way we'll be able to test out all of these functions and see if this is working as expected. All right, guys, so I just created a couple products here. I made them variables so that we can mutate them if we want by applying discounts and stuff, and then created our cart, also a variable, so we can mutate that list of items. And then so this is the starting point of the cart. It has 3 items in it. Then I created another item, and applied a cash discount to it just to test that out. And then we added that new item, P4, and then we're going to say cart.print receipt, and let's just see what we get. And we see that that's probably right. I'm sure we could check the math, and that would be our accurate total there. What I want us to do now, guys, is maybe try to remove an item from our cart, and we're actually going to get a crash here. So let's talk about why. So we're going to say cart.remove item, and let's say P3 or something like that. And this function is going to run the remove item guy, and it's going to start looping through our list of products. It's going to try to find the right one, and then it will ultimately remove it. And we can then say cart.print receipt again, see if it's updated correctly. But you guys notice we got this index out of range error. So this is an interesting problem. And the reason that happens, guys, is when you start your for loop, it's expecting to go through the full range of the array. So if there's 4 items, the for loop's going to run 4 times. But if you remove an item in the middle of the for loop, right, then it's going to change the amount of items in the array, and your for loop's going to go, oh, hey, dude, I thought you wanted me to loop 4 times. That was the original size of the array. Now you've removed something and you sort of switched up on me. So what you need to do is figure out which item you want to remove. Then you're just going to say return to stop the for loop right there. Okay, so now let's go ahead and run this again. And you guys are going to notice that everything is fine. So now that we removed an item that costed, what was it, $900 basically, we see that our total has updated here. And what I want us to do to really polish this problem off, guys, is just go ahead and add some functionality to our receipt to maybe show the user like a detailed breakdown of everything they just bought and the cost of each item, and then display the total. So let's see if we can print something like, you know, item 1 is like MacBook Pro, and it was, you know, $12.99.99, and then do that for each item, and then ultimately print the total at the end. So let's go ahead and write a for loop, and let's think about how we want to do this. So we notice that we need, you know, the number of the item that we're purchasing. So we're going to need to use our index guy in our for loop. So we're going to say for I in 0 up to items dot count. Then we're going to say let product equal items I. So that gives us access to the product that we need. Then we're going to say print item, and we're going to say I plus 1 here, because we don't want to start counting at 0. We don't want to say item 0 is, item 1 is. We want to just start at 1. So we're just going to add 1 to I, and then we're going to say product.name, a couple dashes, $, product.price. Cool. So that's going to print that out. And then let's maybe print out like a divider. And maybe print like total. And then we could just print out get total. So now let's run this guy. So item 1 is a MacBook Pro. Item 2 is AirPods Pro. That was $299.99. We see the iPad is $500, and that has our updated discount, right? Because the original price was $600, and then we applied a discount to it. And then we get our total of $20.99.98. And then, you know, it does the same thing here. So this is when we had all of the items in our cart, and that was the total. But then we removed one, as we saw here with remove item, and it updated our cart to only have 3 items and the correct price. So I think that's awesome, and I think that's a good stopping point there, guys. And this, once again, just gives you an idea of, you know, some of the real world problems you're going to be solving when you start building apps. This is really the foundation of what you need to be able to solve these problems. All of the, honestly, the UI and all that stuff, like building out like screens and user interfaces, that's the easy part of coding. This is the hard part. And the reason I see a lot of people fail is they jump into the easy and the fun stuff first, and they skip over the fundamentals. So that when they actually try to start building complex apps or apps that have any real sort of functionality, it's not just something that looks pretty with a bunch of pretty colors on the screen. This is where they get hung up, and this is where they completely fail. They get frustrated, then they basically quit coding, or they have to go back and relearn all of this stuff anyway. So you guys have gotten off to a really good start here with all of these fundamentals. I keep saying, if it's confusing, don't worry. We're going to get a lot more practice with this exact type of stuff once we start building real life apps. That's where all of this stuff really starts to come together, guys. When you can start building out a mobile application that has a user interface that the user can interact with by like clicking buttons and stuff. And then when they click that button, it will execute some of this functionality. So you'll be able to see all of this come together full circle. It might be hard to visualize it right now because we haven't actually, you know, built out an application to attach this stuff to. It's all just code on a screen. But once we start actually building apps, it's all going to come together a lot more. But like I said, we needed to get the fundamentals out of the way so that we can succeed as app developers and programmers, because this is the real problem solving that you're going to have to do as an app developer or programmer. So guys, the app development fundamentals course is available on my website at stephancodes.com. Check it out. I'll see you there, where we're going to be learning how to build mobile apps. It's going to be awesome. It's going to be so much fun, and it's going to get you guys one step closer to your goals. So we'll see you there. Peace.